Okay. Now for us, the radio transmission is not very important. It's just a vehicle for us to put signals on it. But adding the signals to the radio waves is insignificant to the behavior of the wave. It still travels at the speed of sound. It still be able to be received on the receiver. And on the receiver, we just strip off that signal back to audio. Now that process of adding an audio signal to a wireless signal is called modulation, okay? There are different forms of modulation. We're going to talk about them. Of course, the most known way to modulate a carrier in the analog world is frequency modulation. It's extremely similar to how FM radio works, okay? So let's say we have a carrier at 470 megahertz, and we're going to use frequency modulation, which is FM. And then we're going to have a kind of a audio signal. It could be voice, it could be saxophone, it could be keyboard, anything that is in the audio range. So what happens here, this signal here is our audio signal. And as it is modulating the carrier, it slightly changes the frequency of the 470, which we call frequency deviation, okay? Or a modulated signal. So the 470 will be plus minus the frequency that is modulated on. So I'll give another example here. If my modulated signal is 1 kilohertz, then my overall frequency that is modulated carrying the audio wave will be 470 megahertz plus minus 1 kilohertz. Okay? We also have amplitude modulation, which a lot of people recognize as AM or AM radio. So AM radio modulates a signal by changing the amplitude of the carrier. So the RF signal gets more or less based on the frequency of the audio. So you can see on the top here, this is how amplitude modulation looks like. You can see the frequency is static, but the change is in the amplitude corresponding to the audio signal. Okay. By the way, if for any reason the internet gets stopped or gets hanged, my audio gets stopped, and it's an important information for you to understand, Kelvin, you can tell me, can you repeat the last thing you said? Here, we can see frequency modulation, which we explained in the slide before. The last form of modulation, which was used in the modems when we first used internet over the telephone lines, if anybody used that, it was frequency modulation. Okay. Now, sorry, phase modulation. Phase modulation changes the angle of the wave or the directivity of the wave. Okay. So with this happening, then you will be able to hear the signal based on the changes in the angle of the wave. It's a bit more complicated. It's not used broadly in wireless microphones or in the analog wireless microphones. Most of the analog wireless microphones, they use frequency modulation. This is an animation that I will play for you. It will show you how frequency modulation affects the carrier. So let's see how that works. Just go back to my So you can see here with the change of the frequency, the carrier gets altered. This is a typical example of frequency modulation. Whenever the voice happens, you can see it slows down the frequency a little bit or speeds it up. But that is regardless of the amplitude. Okay. Now, processing of analog systems is very important in wireless microphones. And this is very important for you to know why there's a difference between analog microphones and digital microphones, as in wireless systems. So, the number one factor that we know in analog systems is something called noise. Now, you need to kind of be a bit more accurate about what kind of noise. There's something called inherited noise. And we know that very well when you listen to an FM radio, right? If you're slightly out of coverage, you start getting a bit of, crackling, or you get a bit of hissing noise, or it can be even like white noise in the background. Even if when you get clear signal, an FM, let's say on your local channel, when the music stops for any reason, for a second or two, there's always a hissing in the background. It almost feels like you have an amplifier on max, okay? That hissing is inherited. They call that, a residual noise that is from the circuitry, and it cannot be avoided. It can be reduced, it can be worked around, but you cannot get rid of it. It's very similar when you have a average preamp and you need to put the preamp gain high, you start getting that noise in, okay? This is very similar. So let's compare the signal from the transmitter. We have it on the left side here. And then on the right side here, we have the receiver. So the receiver is going to receive the signal on the top like this. And then when it demodulates it, it's going to demodulate it down like here. And you can see it contains noise compared to the source. So the source is a very smooth line. Here it's slightly adding noise to it. So there are some processes done on the transmitter and receiver to reduce that noise, but it is on the overall frequency response. Yeah. Excuse me. So this is a very straightforward block diagram of transmitters and receivers. So what happens is we have limitations in the transmission in general in the analog world. The two limitations, we mentioned one of them, which is noise. The second one is something called dynamic range. And to give you an example, again, about the dynamic range, is that when you ever listen to a FM radio, to a song that you already have a copy on your phone with it, or on a CD, you find that the sound is more saturated, it's more compressed on the FM radio. You feel that, the high frequencies are kind of absorbed whenever the bass kicks in. Now, the reason why is that the analog modulation in the FM radios is limited. It's only 50 decibels of dynamic range. But we are used to at least 100 decibels of dynamic range in our, let's say, digital players, like your phone output, or even in your standard mixer. So when you plug in your microphone or your mixer, you can easily get 100 decibels of dynamic range. But on an FM transmission, you are only limited to 50 decibels of dynamic range. Those who ever used Bluetooth modulators on their FM radio in the car, I'm not sure how many of you use them. I know the power is out, so I'm not going to see a lot of you. But anybody knows about the Bluetooth modulators where you plug it in your car lighter and you plug that into your phone and then you listen to music on your FM radio? Anybody used these before? Kelvin, can you give me some feedback? I cannot see the screen because of the power. Okay, so I can see that some people know about them. So first thing that we notice about these Bluetooth modulators is that the first thing you feel whenever you connect it is that you cannot get the same volume of your local radio channel. You need to kind of increase the volume on your radio to a very high level to get almost the same level that you're getting from a local radio station. And if by mistake you switch to the local radio channel before you lower your volume, it almost blasts your car. And if you try to increase the volume on your phone, you find that the music gets distorted. So you need to lower the music on your phone, increase the volume on your radio in your car, on your receiver to a very high level. This is, again, the same example of limitations in the dynamic range of FM transmitters. So for wireless microphones to feel loud and clear, just like any wired microphones connected to your mixer, we need to add the audio processing. The first thing we do is something called noise reduction or a pre-emphasis. Okay? The pre-emphasis is a process of increasing the treble by 12 dB. So the audio processor here in the transmitter is increasing the treble by 12 decibels, something we call the companding algorithm. A lot of us hear about it as like, oh, analog systems has a companding algorithm, especially in in-ear monitors. So what we do here is that we need to compress the 100 decibels of dynamic range half the way. And then you modulate that into your FM transmitter. What happens in the receiver then? You need to reverse that. That's why we call it companding, because in the receiver you put an expander to expand the 50 decibels of dynamic range back to 100 decibels of dynamic range. So you compress on the transmitter, you expand in the receiver. That's companding. And then you do a de-emphasis. So we did a pre-emphasis in the transmitter. Now you do a de-emphasis in the receiver, which is very much like having an equalizer on your frequencies from mids to highs, or on your treble register. But you're reducing your treble by 12 decibels. But what happens here, you also get rid of the hissing in the background. Okay, so this is showing here some of the processes. You can see that we have 100 decibels of dynamic range in the transmitter. Then we compress that to 50 decibels, so we can modulate that on the FM transmitter. And then in the receiver, we decompress or expand. And of course, another process here is the pre-emphasis and de-emphasis. You can look at this as like an equalizer curve, a parametric EQ, or like a shelving EQ. So on the transmitter, we are boosting treble, sometimes even up to 24 decibels, depends on the system. And then in the receiver, we are reducing these frequencies back again by the same amplitude. So if you boost 24 dB, you need to cut by 24 dB, and it's back to be flat again. But the question is this foolproof? Is this 100% accurate? Of course, the question is no. This is why analog systems are not 100% accurate to the source. A lot of you used to ask questions like why the Beta 58 does not sound the same on the BLX system like a Beta 58 when it's wired, or a Beta 87 condenser microphone. It's like, I'm a very old user of Beta 87. I use it in my studio all the time. But when I got my SLX analog with a Beta 87, it did not sound the same. And this is the answer. The answer is, number one, you have a companding algorithm. Number two, you have a pre-emphasis and a de-emphasis under the hood, which limits the frequency response of the overall system. People are still using UHFR today. If you compare it, for example, to QLXD, ULXD, SLXD, or even Axient, you can hear that all the digital systems are way more transparent. It sounds more crystal clear. Doesn't have noise in the background. It almost sounds as good as a wired microphones. And this is the main reason. So we talked about the audio processing. Now we're going to talk about the RF processing. So to summarize audio processing, we have the de-emphasis and pre-emphasis. And then we have the companding algorithm, which is compression and expansion. Now, in the RF side of things, it's very simple. All we need to do is something called a modulation and demodulation. Now, in electronics, it's slightly more complicated. You need to understand that too much. But as I said, the most important thing in a journey is the passenger. It's not the method of transportation. If I want to go from Dubai to Nigeria, I need to take an airplane. Now, do I take the airplane under my armpit when I get out of the airport? No, I leave it at the airport. I just step on it in Dubai, and I step off from it in Lagos. So this is the same thing in any kind of communication. In the transmission, you modulate your RF signal that travels to the receiver, and then in the receiver, they strip off the signal from the carrier, and they call it a demodulation. They keep the signal that is modulated, and they remove the RF signal. You don't need it anymore. Okay? I'll skip this because we already explained that. It's a bit more technical. There's no need to go through this. Front-end filters. This is a very important topic. It can be very technical as well. I'll try to simplify it as much as possible. Every wireless receiver at the front end where you connect the antenna, there's a circuitry behind that, which is called front-end filters. You might hear that term sometimes. Some of you might not have heard it before, but it's very important to understand this concept because a lot of people take the cascade for granted. And what does that mean here is that when I use multiple devices and I cascade from the antenna outputs to another device, my front-end filters are always affecting my signal, okay? Which means if my first receiver is, let's say the tuning range is 520 to 600 megahertz, it will have a front-end filter that will only allow 520 to 600 megahertz to pass through. But my cascade out will also be subjected to that front-end filter. So what is the frequency coming from the cascade out will be? A lot of us think it's 520 to 600 megahertz, but in reality, no, it's going to be slightly below 600. Now, what if I do a third cascade, which I do not recommend, by the way? I only recommend 2 devices in a cascade, your main device and a slave device. Going with a third and fourth device in your cascade, it's not recommended. If you need to do that because you have a problem, you cannot find a way out of it, then you need to be aware of your front-end filters. Number one is every cascade you do, you lose 3 decibels of your gain. Number two, every cascade you do, your edges of your frequencies are being chopped. So if your frequency range on your first receiver is 520 to 600, the first cascade is going to be slightly above 520 and slightly below 600. If you needed to do number 3 and 4, you need to go more center in your frequencies, okay? So don't take your cascade for granted.
Hi, Barry.
Now in the accent digital,
Can you hear me, Barry?
yes,
So we've lost
tell
you a
me.
long time ago. We're having power issues here. So you might have to go back to FM signal.
Can you tell me from what?
Okay, so you might have to go back to processing of analog signal. We lost you. We're having power issues here at the facility.
Okay, are the speakers on the UPS or not?
They are, but we had a long power out, so the UPS ran down.
Ah, okay.
Yes. Sorry for taking
So
you back.
did you manage, no problem. Did you manage to get your speakers on a backup, another backup?
Okay, maybe we'll work towards getting another UPS, but we're hoping that we'll not have any power issues again.
Problem. But now it's good to go. I can
Yeah.
repeat or should I wait?
No, you can go on. You can go on. Thank you. Proceed.
Go on. Is that where you lost me or before that?
3 slides back. Viewing FM signal. Module 3.
What?
Module 3. Yeah, here. Yes, yes,
Yeah.
yes.
Oh my God, that's like almost like half an hour.
Yeah, sorry.
Okay, I've lost what I've lost what we said here.
All right. All right.
Okay,
Yeah, you can continue.
come again.
Proceed. You can proceed. You can proceed, Barry.
Okay, okay. So, okay, I will. So this is where I was showing the modulated signal, how the modulation happens. So it's an animation. So okay. So I have a suggestion, Kelvin.
Okay, Barry, I can hear you.
Can you hear me, Kelvin?
Yeah.
Yes. This session has been recorded, by the way.
Yes, it
Okay.
is.
So what we'll do is when this is done, we will send you a recording for this, which you can share with everybody online and offline.
All
Okay.
right. All right.
So
Noted.
this way would not have to waste another half an hour. Okay.
Okay. Okay. All right. Thank you.
No problem. So I'll move forward right now to the front end filters again because that's quite an important topic.
Okay.
Okay.
All right.
So I'll repeat the front end filters so this way we can carry on from that one.
All right.
Front end filters is a very important part of every wireless system. It dictates what the wireless system is able to hear from the spectrum. Okay, it's pretty much like when you wear sunglasses. When you wear sunglasses, you want to eliminate the UV from the atmosphere so it not hurt your eyes. It's the same thing with the front end filters. It only allows the certain frequencies that the system operates on. So if you have a receiver, for example, works on 520 to 600 megahertz, it will be equipped on the BNC connectors on the inside. There's a circuitry that will only allow 520 megahertz to 600 megahertz to pass through. Okay, but what about the cascade outs? And this is where things get very critical. I know a lot of people do a lot of cascades, and this is where things need to be taken care of. Your cascade outs will be subject to your front end filters, which means your cascade out will allow a second device to tune on slightly above 500 megahertz and slightly below 600 megahertz. Okay. Now, if you need to use a third and fourth cascade, which I do not recommend, you have number one, more losses because every cascade you lose 3 decibels. Number two is that your tuning range is going to get even narrower. So it's going to be way more above 520 and way below 600 megahertz. So third and fourth cascades are only allowed when you are out of options and you need to get the show going on. You need to make sure on Wireless Workbench that these devices are limited to a narrower tuning range, and you need to tune more to the center to get more efficient operating range. Now, the only device that has active cascade, because everything else has a passive cascade, is the Accent Digital. Still, doesn't mean because it's an active cascade that you're going to get the same frequency range. The front-end filters will still engage in that case. The only thing that will be allowed is that you will not have losses in the gain. So you're not going to lose 3 decibels whenever you do a cascade on the Accent Digital. Nevertheless, if you switch off that device and you have devices after it, these devices will not get radio frequency anymore because it's an active cascade. Excuse me. Now, squelch is a very well-known method in reducing, let's say, RF noise, which is usually translated into white noise. So whenever you have an RF signal, there's no issues. There's no noise. But the absence of RF generates a lot of noise, which is called the white noise. If you remember television, when it's, when the transmission ends on the television, you get that white snow on the screen, or it's called also white noise, and it's very loud, especially for those who usually doze off on the screen at night. They're watching a movie, and then half of the movie they fall asleep. And then after the movie, they said, like, thank you for watching our program for today, and now we're signing off. You're still asleep, and whenever they stop the transmission and you hear that burst of white noise, you wake up. So white noise from the absence of RF is very loud. That's why in the early days in wireless microphones, they use something called the squelch. The squelch is pretty much like a noise gate, the same one we use on our digital mixers. So whenever the signal is higher than a certain level, it will allow the signal through. If the signal is below a certain level, it will shut the gate and mute that channel. Now, the advantage of this is that whenever there's white noise, it gets muted. But the disadvantage is that sometimes a spike of any electronic device, like a drill, like a welding machine, it could be even, a light switch, can emit radio frequencies that may trigger the squelch on. So that means it might fool the receiver that, oh, there is a signal. What happens in the receiver that opens the gate, and then a burst of white noise will come through. So imagine if you have a big line array system and a burst of white noise just passes through. It might freak people out. So what happens here is that the threshold or squelch threshold is not always a preferable way to use it as a way to suppress white noise. So manufacturers went into something different, especially in Shure. So Shure in their analog systems, like in the BLX and the analog SLX back in the days, they use something called the tone key. Now the tone key is a way, it's like it's a way to signal to the receivers, like flag it. If I'm getting the red flag, you take that as a signal that don't pass audio. If I give you the green flag, you take that as a signal to open audio. So these tone keys usually are happening outside of the audio spectrum. So in most situations, it could be in the 30 kilohertz. And as you know, audio frequencies is between 20 hertz to 20 kilohertz. So 32 kilohertz is not going to be an issue. It's going to be inaudible, but that will be detectable by the receiver. The most important part also of the tone key is that any disruption in your transmission because of obstacles, because of noise, interferences, will affect the tone key first before it affects the audio signal. So what happens, any distortion in the tone key would let the receiver shut the audio directly. And this is when we call them dropouts. So whenever you're using an audio, let's say a digital system or an analog system, and you're out of coverage, and you get these blips of muted sounds, or your speakers saying something, and you're only hearing parts of it. This is because the tone key is getting disrupted. But also the tone key is able to transmit more information. So it's no longer only that now I can also transmit the battery life, I can transmit if the transmitter is locked or unlocked, I can transmit that, the RF signal, how much is it, or the audio signal, how much is it, and so on and so forth. Now, we understood about analog transmission, and for the part that got, absent from the power outage, you can watch the recording again and you'll understand all of it. But now let's talk about digital transmission. Now, we have something called hybrid systems. So what happens is that we have a digital signal processing for the analog systems before it gets modulated. And you can find that, for example, in the in-ear monitors. So all of the in-ear monitors today from Shure, they have a DSP that does a digital signal processing for the analog signal before it gets modulated, which adds more accuracy to the signal. Okay. So this is the hybrid mode before we go into a pure digital modulation. Now, why digital modulation is is preferred today? Simply because, as we know, digital it's either a 0 or a 1. There's no in between. While in the analog signal, you have a lot of variations from 0 to infinity and back from infinity back to 0 or to minus infinity. And absence of any part of that signal is going to affect the transmission or the integrity of the signal. In digital signals, you only need to transmit zeros and ones. And you don't really care about anything else other than transmitting zeros and ones and receiving zeros and ones. And that is actually much simpler and adds more integrity to the signal than doing the analog way. Now, in digital modulation, they use different methods. It could be a combination of all that we mentioned before in terms of amplitude modulation or frequency modulation or phase modulation. Also, they have something that is called a shift keying. Shift keying is a way to make the amplitude modulation or the frequency modulation or phase modulation even more complex in forms that you can actually carry more data. In other ways, you are allowing more bandwidth in the same carrier. So to give you an example, which we mentioned earlier today, it's the modem that we used back in the days to access the internet. So if you want to see the bandwidth of the phone lines in general, the bandwidth of the phone lines is in the range of 4 kilohertz. And frequency response is pretty much from, let's say, around 400 hertz to about 2.6 to 4 kilohertz. Okay, depends on the phone lines. But if I want to use that to transport audio, it's horrible. I mean, you can barely hear audio. If you're waiting on a let's say on a call, you call your bank or you call your internet provider, and they put you on hold and they play back music in the background. The music is always distorted and you cannot hear it very well. It's not because the music was distorted, it's just because the phone line cannot allow more bandwidth. But that same phone line, by the way, when it's used via something called a modem, which increases the bandwidth here, but based on time, it increases the bandwidth. And it uses a combination of amplitude, frequency, and phase modulation in the analog world on the same phone line to allow more data. So then you can probably download an MP3 within 15 to 20 minutes of 5 megabytes, and you can listen to an audio signal that is 20 to 20 kilohertz. But if you use the phone line directly, it can barely pass through audio anyway, right? So shift keying even adds more edge to that. So it adds more bandwidth to the same carrier in that case, okay? Here are examples of how digital modulation works. So we have a carrier on the top here. Just go my laser pointer. Sorry. So this is my carrier. Let's say it's 470 megahertz. And then I have a digital bit stream. This is coming from a capsule or a lavalier microphone that is being preamped using an analog preamplifier, but then you do a conversion from analog to digital. So that means these are the zeros and ones that represents the audio signal that you have. And now we are going to use a form of modulation. Okay, based on what I'm seeing here, this is a phase modulation. Okay, so that's a phase key modulation, or FSK, PSK, sorry. And then the transmitted signal will look this, which is the signal plus the noise that is carried. But when I demodulate the signal in the receiver, so this is the demodulated signal, and then now I'm demodulating the audio signal back to its bit stream, to the zeros and ones. Digital wireless systems, noise is not a problem anymore. We care about signal to noise ratio, and we will learn about that more when we talk about the accent digital. Most important factor for the user when it comes to digital systems is the fingerprint or the footprint in the RF spectrum. So if you look in the analog world, you can see that actually this is reversed. On the left is actually digital, and on the right it should be the analog. So in the digital, it's actually narrower, okay? It doesn't take more of your spectrum, okay? And in the analog, the carrier is wider, takes more space, okay? When it comes to noise, which is we call the intermodulation distortion, now it's right. So the modulated signal will look like the right signal, the right screen here with the digital gets slightly wider, but not too much. But in the analog, it gets very, very noisy, very, very noisy, because you get something called intermodulation distortion. And that prohibits using a lot of microphones like you do with the digital system. So a good example is everybody knows with the BLX, you can barely get 8 working channels together. But with the SLXD, you can get up to 34 channels working together, though both systems are kind of using the same carrier, but one is in analog, one is in digital. Now, we also have something called high density mode, where you do not need a lot of power, and then your carrier gets even narrower. So the deviation usually in the standard mode is about 200 kilohertz. And you need to do 350 kilohertz spacing, okay? So that means between a channel and the other, you need to have a space of 350 kilohertz. Now with high density mode, we can shrink the deviation from 200 kilohertz to become about 100 kilohertz. And then your spacing can be within 125 kilohertz, which is very, very tight. So in real life, it's like asking 2 people to sit in one seat and both people are very comfortable, okay? So the advantage of digital system is simple here, is that number one is that you have more simultaneous systems. You can run more channels in that case. And of course, you can have high density mode in that. So let's say in ULXD, you can run 63 channels in only 1/8 megahertz of tuning range. Same thing with the Accent Digital. Of course, you have a better audio fidelity. You're gonna have pretty much like wire sounding system. It's gonna also be very authentic to the source because there's no longer any audio processing done on board. Other than the preamplifier, you have nothing else. There's no compounding, no pre-emphasis or de-emphasis, no changes in the dynamic range. It's authentic to the source. And if you are using digital outputs on your receiver, you are going to get even higher dynamic range because you are limiting also the output preamplifier, okay? And all of these result in less audio artifacts. So you can have less whistling, phasing, any kind of sounds that are not from the audio source, okay? People hear that especially when they use saxophone on an analog system. And if the sax is playing loud notes and high-pitched notes, you start hearing things on the receiver that is not belonging to the saxophone, and these are called artifacts. In the digital system, you do not get that any of these artifacts at all. Of course, you have a very big improvement in our performance because you do not have a very wide deviation anymore. And of course, in that case, better resistance to multipath and intermodulation distortion. So you might hear sometimes that digital systems do not introduce intermodulation distortion. This is an inaccurate statement. It does introduce intermodulation distortion, but it's very less, it has less impact versus analog systems. So you need to pay attention to it, but not as much as you used to do in the analog systems before. And of course, you are able to introduce encryption because you have zeros and ones. You can code these zeros and ones and encrypt them, in which anybody with the same receiver will no longer be able to demodulate that signal. But with analog systems, you cannot limit that, okay? So let's talk about the way you can design RF, let's say, systems in general, and how you need to look at factors that contributes negatively into your atmosphere. So multipath interference is one of the most things that impacts your transmission. A lot of people suffer from that. This is the main reason why we use two antennas on the receiver, or we call them the diversity antennas. So let's look at how the direct and indirect signal gets received on your RF receiver or your wireless microphone. So we have an animation here. Let's play it back. So you have A and B, antenna A and B, and you can see that the person using the microphone is moving around. Because of the reflections, one of the antenna will get stronger signal or a weaker signal versus the other. Okay. Now, how does it look on the inside? This is very, let's say, similar to what we use in the SLXD, QLXD, which has a combiner usually. But to be more precise, the passive combiner is actually in the BLX system. Okay, so in the BLXR particular, because the BLX does not have antennas, so you're not going to see that. But in the BLXR, you have two antennas, A and B, and then you have a passive combiner that combines both together. And the system is pretty much is kind of being selective. Now, switching diversity, this is where it happens in the SLXD and the QLXD systems. You have a switch on the antennas, on A and B antennas, and then on the receiver, it's sending a feedback to something called a comparator, which keeps comparing the final output to whatever the antennas is providing. But it's not on the pre side of the antennas, it's on the final output. So what happens if the system detects a dip in the signal, a loss in the signal, it automatically switches to the other antenna, assuming that there is a better signal. So they call the system a predictive switching diversity because it's based on prediction. In the ULXD system, there is a slightly different approach here, is that the switching is done on the audio side instead of the antenna side. So the comparator is actually checking the audio on the receiver. And based on that, it selects which receiver to pick up the signal from, receiver A or receiver B. Okay. Now, we're going to have a animation here. This animation is going to show you how the predictive switching diversity works in real life. So let's look at it here. We have two lines, the yellow line and the red line. And we can see that the loss of the red line will switch to the yellow line. And this is in a normal situation where there is not a lot of noise, so things are fine in that case. Now let's look at how the system performs when the noise is higher. This is with high noise. So the blue cloud here is actually noise, could be from anything, LED screens, digital equipment, dimmer racks. And then you can see that the system is unable to determine where is the final destination or which antenna has a clear signal. Okay, it's due to the noise. So the noise is it's working like a cloud or like a foggy cloud in front of you. Okay, and that happens a lot when your antennas are either further apart in a QLXD or ULXD system, which also applies even in SLXD. So this is why we recommend that your antennas to be slightly closer than average with these systems. So you would avoid a repetitive switching in that case and loss of audio. Okay. This is in the ULXC system. And then we have something that was used in the UHF-R back in the days and in the accent analog, which is called an audio combiner. And the audio combiner here is pretty much like a DJ fader. So when you fade between two channels, you're not going to have a drop. You're not going to have a mute between the switches. So you just keep fading the audio based on the strength of the signal. Now, all of that was happening back in the days with the previous systems. Some of them still exist. Some of them are not there anymore. Now, one of the reasons why we categorize the ULXD or QLXD or SLXD to be more for less, I don't want to say less important, but I see, let's say, of a slightly lower profile, okay, versus broadcast. So in broadcast stations, you need a system that is very, very accurate. But in other situations, if you have a panel, if you have a discussion, a corporate discussion, it's more forgiving in that case, okay? While in broadcast, it's less forgiving. So in broadcast world, even the smallest switching noise or blip or mute is not recommended. So in the Accent Digital, we developed a system called a true digital diversity, okay? Now, true digital diversity is quite unique because instead of having a comparator that switches antennas or switches receivers, now we have something called like an error correction, okay? Which is like a summing stage that keeps comparing the digits from two receivers. And if you have a lost digit in A, it will correct it from B, and vice versa. Let's see how that works. Again, we have two signals. They're being received by antenna A and B. Whenever one of the signals gets weaker or stronger, both receivers are still receiving the signals all the time. But since in that case, the receivers are getting the signal with full integrity, there's nothing happening here. Your summing stage is still reconstructing the audio in that green form here back to its original form. But let's see how it works when there's more noise. So when there's a loss in the signal or lost digits. So you can see here that we lost some signals from the antenna A, but it was available in B and we got recovered. But whatever was lost in B was recovered by A. Now we have lost in A, recovered by B, and so on and so forth. But if you look at the output, the total output, it's absolutely zero loss, okay? Apologies about this. Let's go back into presenters modes. Let's see with high noise, what's going to happen. With high noise, you're going to have way more losses. You can see that every other bit is being lost, but it's not the same bits that are picked up by antenna B. And still, the signal is being reconstructed with full integrity. This is one of the main reasons why the Accent Digital here has more edge even against the ULXD, which is the closest system that operates with the same principles, at least. So whenever we say that the Accent Digital has a very different engine in terms of how it operates, this is exactly what we mean here, is that yes, both are digital wirelesses, both have high density mode, both have the same channel count, but the way that the Accent Digital receiver operates in terms of demodulating the signal and does the error correction is not the same, okay? And because of this, the Accent Digital gives you more edge in terms of coverage as well. We're about to see that later on today. The other thing is the Accent Digital has an ability to do a combination of receivers. So what happens in the quad channel, in the accidental quad, AD4Q, you are able to use 4 receivers together, and then you are able to do error correction on 4 levels, which is quite significant here. I mean, that gives you a way better edge even versus just using a standard A and B receivers. The only downside here is that your quad becomes a dual receiver because you are borrowing 4 receivers, 2 for each channel. So that means you're going to be out of receiver. Okay, so you only have channel 1 and 3 in that case operational. Now, a direct use for this is when you have a massive stage and you have a green room, or you want to do an interview in a green room, you want to put it on the LED screen, you know, that big artists, and people get, you know, more excited to see this. They feel, you know, that's more real than a TV screen. So their favorite artist is being interviewed in the green room. He's saying, I'm right now in the green room. I'm going to be out in the next 5 minutes, guys. But before I'm going to go out, I'm going to play you back my latest track. And we're going to watch it together. And as the track is playing, he actually holds a microphone and he sings along with it as he's walking on stage from the green room without any interruption. This is a typical example. Or when you have a catwalk, the catwalk is extended way out of the stage area and it needs a special coverage. So in quadversity mode, you can use that. So you can use another pair of antennas for the catwalk, your regular pair of antennas on stage, and you have the full coverage. In sports events, a lot of the times they have interviews with the players when they are still in the tunnel before they go on the actual playground. And usually in the tunnel, there's no coverage. So when you use quadversity mode, you have special antennas covering the tunnel. Then you can do interviews inside the tunnel, and you keep your regular operation on the main playground. So in general, right now, we're talking about the quadversity mode and how it's being used. Now we're going to talk about something called frequency diversity mode. Frequency diversity mode exists in the ULXD and in the Axon Digital. In the ULXD, you can use 2 body packs and over 2 channels, and you can do something called frequency diversity, which in that case, a loss of one of the signals, you already have a backup with the other one that is providing a signal for you. In the Axon Digital, it's more complicated in a different way. And when I say more complicated, because it's more robust in that case, you have options to use your AD transmitters, your standard transmitters in that case. So just like ULXD, but in other ways, you can also use the specifically designed transmitter, which is the ADX2FD. It's a transmitter that has 2 transmitters inside it. And when you sync it to a channel, automatically it gets both of your channels engaged. So I'll demo that to you. I already have a frequency diversity handled here, and I already have it synced to my receiver. Now let's talk about antennas and antennas design. This is a very, very important topic. But I'd like to call for a 5 minutes break. Kelvin, are you with me? Kelvin? Can you confirm we can go for a 5 minutes break?
Okay, that's fine.
It's fine? Okay.
Yes, yes.
So now it's 53, or it's actually almost 5 minutes before the hour. So we get on the top of the hour.
Okay. Yeah. That'll be 12. That'll
See you
12
in
now.
5 then.
All right.
Keep everything on, just mute.
If you didn't get, hello, if you didn't get water, please come to the back to get it. Thank you.
Also, if you haven't checked in, please meet me. Like, I got you. If you haven't checked in, please, please meet me if you haven't checked in. All right, cool. There's also a Q&A section. Please, if you haven't checked in, please meet me. Thank you. Again, please, if you haven't checked in, please come to the back to do so. Thank you.
Hello everyone. If you're yet to check in, please do well to come to the console. Thank you so much.
Tired of wasting time finding high-quality expired domains? We understand your frustration, and we have a solution.
With this feeling, I can leave. I'm working and I'm leaving. Will you dare to give it all up and walk by my side? Do you see the road? Do you hear its call? Do you want a part of it? Just getting me above now. Just getting me above now.
So you can see the charts. Let's fix my mic as well. talk about antenna design basics. This is a very, very important topic. A lot of people make mistakes when it comes to this. I can see somebody that is calling me from your side. Can you tell me anything? Should we start or there's any issues?
Okay, everybody, can we settle down? Barry is ready for us to start, please. Barry, can you hear me?
Hi, Barry.
Hello, Barry. Barry?
Can you hear me?
Yeah, I can hear you. Can you hear me?
I can hear you. Can you hear me?
All right, we can hear you. I think we're set to start.
No, sorry, let me talk to you. Barry.
Yes.
Barry.
Yes. Hey, tell me.
Barry, can you hear me?
Can hear
Is
you,
my mic
yes.
muted? Is that yes? Okay. So I wanted to confirm if.
Yes, I can.
Okay, so I wanted to confirm if the link will be open for the people joining online, even when you drop out of the meeting.
I can see that there are 54 people already
Online?
in the poll.
Okay.
Yes.
All right. So I'm asking to know if that link will be open for the people, even when you drop out of the training.
The link will be active as long as we are in. So
Okay.
if
Okay.
people drop out, they can rejoin using the same link.
Okay. Okay. All right. Thank you.
There is a Q&A tab for
Okay.
people who have any questions who want to ask there. So I will read this towards the end. So
Okay.
I will just type in where they can do that.
Okay. All right. Noted. So we are back from the break, so you can continue.
Awesome.
All right.
Great. Okay. So let's continue then. Can you just switch your camera to the audience so I can see? Paste. Okay, so now we're going to talk about antenna design basics. It's one of the most sought after in terms of information. This is where a lot of people make mistakes. It's where a lot of people also misunderstand antenna placement and how to use them as well. So to start first with the types. So generally, the size of the antenna, as we mentioned at the beginning of the training today, is respective to the wavelength. The higher the frequency, the smaller the antenna because the wavelength is shorter. That's why microwave antennas are very small. Long wave antennas and HF antennas are very big. Now, from Shure, you can have an option of wideband and narrowband options. You can also get directional antennas versus omnidirectional antennas. Now, there's a difference in the efficiency. Usually, directional antennas are more efficient than omnidirectional antennas. So in that case, you need to be really careful with how you select your antennas. Narrowbands usually are more efficient for transmission versus reception. And they're more critical in that case. So when you're using PSM systems, you need to have more narrowband antennas versus when you're using just wireless microphones. This is a comparison between a VHF antenna for, let's say, some of the systems that we got. They operate in the VHF range versus the UHF. You can see the size of the antenna is almost double the size of the UHF. Okay. Now let's start with the half-wave antennas, or they call them dipole. The reason why they are called dipole is that they have two poles. You can see here there's one pole going upward and there's one pole going downwards. And the maximum sensitivity of the antenna is the tip of the antenna. Okay, it's not the bottom, it's not the body of the antenna, it's the actual tip of the antenna. That's the most sensitive part of the antenna. Okay, this is where you see that red shading on. Now, what is the difference between a quarter wave and a half wave? Quarter wave is very similar to the telescopic antenna, the ones that are usually on the system, like the ones on the BLXR or the ones on the SLXD. These are usually quarter wave antennas. Now, why is it a quarter wave? If we look at the first image on the left here, we can see a half wave antenna, which has two poles, right? A dipole. Now, with the quarter wave, it's half the half wave, which means a quarter. And why is that? Because you only have one pole showing, but the other one is the ground, or the chassis that you mount the antenna on, which we call it the ground plane, okay? So you can see here that is imaginary, or it's invisible. So that's why you only calculate half of the half, which is a quarter, and that's why you need to think about it this way. Now we have a side view to an omnidirectional antenna. So if you look at it from the top, which is the overhead view, it looks very much like a omnidirectional. It's a circle. But from the sides, it's a donut or toroidal. So from the top side, there's no coverage, or the bottom, but around and about, like a toroid or like a disc, there's coverage. With the fin antenna, or we call it the directional antenna, it's like a cardioid polar pattern, and we can see, like, you know, the heart shaped. So from the back, there's less sensitivity, and it's more sensitive to the front. So it has something called forward gain. Usually the forward gain is around 5 to 7 decibels, and the dispersion angle is about 60 degrees. Then we have a half cardioid, which is the wall mount antennas, like the 864. So the 864 is half cardioid, and it has a dispersion angle of 60 to 75 degrees. Okay. Let's back one slide again here. This is the 874 or the 805. The 805 is a passive. The 874 is the active version. Okay. Last in the family here is the helical, which is I think it's the 8089, and we have the 8091. Both of these antennas are, let's say, they are helical. We have the dome and we have the standard. You have one in the room already right now. The helical antenna is non-polarized. Okay. All the other antennas are polarized. Now, also the pickup is slightly narrower, 60-75 as well. But the most important thing about the helical antennas is the forward gain. It can give you up to 15 decibels of forward gain. So we have narrow band, we have wide band. Most of the UA8, they are narrow bands. They are tuned specifically to a very small tuning range, while all the other antennas, the bigger versions, are actually wider bands, and they can cover up to 600 megahertz. In the world of RF, this is a very, very wide band. Okay. Let's talk about forward gain again in more details. So certain antennas automatically or by nature, they have enough gain, they have enough boost in them. So we're talking about, for example, the UA864, it only has 3 dBs of forward gain, while the PA805, UA874, they're in the range of 7 dBs of gain. And then the 8089, the helical antenna, like the one you have in the room, this can give you up to 14 decibels of gain. Now, active antennas are very misunderstood in the world of RF. Reason why is that, thank you, boss. Active antennas can be very misunderstood because a lot of people think that active antennas, they can be better performance than passive. And this is not 100% right. The reason why active antennas exist is to actually be able to work around noises and cable lengths. So a lot of people try to boost the active antennas on the back, especially 874. They put it on +6 or +12 whenever they have issues. And they realize that their issues is not being resolved. Reason is, if you have noise, you boosted the noise by 6 decibels or 12 decibels, okay? And if you have what they call it as intermodulation distortion, you make that even more prominent by 6 to 12 decibels, depends on what switch you do. So there's a reason to use these, okay? One of the main reasons is when you have LED screens. I know a lot of the venues in Nigeria, they have LED screens. You know, there's a guy from Deeper Life. I've seen their LED screen there. It's massive. And when you have an antenna close to an LED screen, that LED screen is going to emit a lot of unwanted noise into the antennas. So I remember 2 years ago, they had an issue. They been in touch with me, and I told them, first thing you need to do is remove the antennas from the LED screen, put them aside, and let them point towards the microphones and not on stage directly. So this way you're reducing a little bit of the pickup, but it will be also useful to pad the antennas and put it on -6 dBs in that case. So what happens is that you make your antennas weaker a little bit, in which the noise will be eliminated, and you put your microphones in slightly higher power. So this is one of the ideas of using active antennas. Why active antennas are useful when noise. Thing for using the boosts on the active antennas is when you have long cable runs. You have a 30 meters cable run, and you're using an antenna. If you do not have a boost on your antenna, your signal will be dead inside the cable before it reaches the receiver. So then you need to boost your signal a little bit to overcome the losses of your cable. The downside of this, if you have noise, you already boosted the noise. So you need to be careful with these. But the bottom line is, do not misunderstand active antennas as boosters, like the ones they used in television back in the days. They do not work the same way. Now, how do you choose your antenna? What are the basics of using antennas? When are antennas used in the right way and when they are not used in the right way? There are many aspects here, okay? The first thing that dictates the antennas is if you have obstacles, if you have things to eliminate. But if not, your Omni antennas will give you a very good coverage. It'll give you a very circular coverage if you need a circular coverage. And they are quite good for 30 to 100 meters. Generally, depends on the system you're using. Shure is always giving you the safest figures. So when they say 30 meters, they are 100% sure that 30 meters will work, okay? But with an Omni, that means 30 meters around the Omni. So that's going to be 60 meters side to side. Now, directional antennas will give you slightly more coverage because they have forward boost, and then will give you easily up to 100 meters of coverage in the forward direction, assuming you do not have any noise. And it's also rejection. It has rejection from multipath. It has rejection from the backside of the antenna on the fins. So this way you are eliminating noises if you know the source is coming from a certain place. So if you have dimmer racks behind the stage and you have LED screens, then you make sure that the backside of the antenna, the longest shaft or where the boost circuit is pointing towards the side you do not want to pick up the RF from. And you can see port number 3 is saying active antennas to compensate for long cable runs. This is the primarily used. But we add to that also padding unwanted noise sources. Well, antenna placement is very important here because it's based on the polarization of the signal. And this is something I haven't mentioned earlier today, is that the only antenna that is non-polarized is the helical antenna, but everything else is polarized. So one of the main reasons why we put the antennas in a 45 degrees from the horizon or 90 degrees from each other is to accommodate for all possibilities of your signals, especially with body packs. Body pack antennas are very directional or very polarized. So if you're holding the body pack vertically, it will send a vertical signal. If the body pack is mounted in your belt horizontally, it will send a horizontal signal. So if your antennas are set up to be vertical, whenever the body pack is held sideways, it's going to have 50% of your power, or you're going to have a dropout. So if you look on the screen, I know that my picture right now is quite small, but when I switch off the PowerPoint, you're going to see that my antennas here on the rig is already panned 45 degrees or 90 degrees from each other. And there's a main reason for this. So whenever you set up your antennas, it's always good to have a 45 degrees or 90 degrees from each other. This way you make sure that you have all the coverage possibilities. Now, to move into what you should not do, which I see a lot of people in Nigeria do, unfortunately, it's antenna jungle. Every time I show this slide, I see people smiling because they remember what they have in their church or in their corporate or in the live scene, and they know that this is what they do most of the time. I remember once I got a call for a problem with the in-ear monitors, and I found them mounting the fin antenna on the I-beam, extremely close to the I-beam. And they said, they're not getting coverage. Though the antenna was almost 15 meters high, but it's actually mounted on the high beam with a gap not more than a couple of inches. So the I-beam is absorbing all the signal out of the PSM 900 that they were using down there. And pretty much it caused massive damage. So the first thing we said, let's move the antenna, put it on a microphone stand. It will perform much better than the 15 meters high I-beam that they have. Now, second thing is the antenna farm. When you have all your racks put in or all your receivers put in one rack, and the antennas are just suspended behind the rack. This will never work properly. The only antenna that will work is the one on the top or the one on the bottom, depends where the microphone is. But everything else in the middle will not get the signal. Reason why is the first antenna is going to block the rest of the antennas. Now, staggering them left and right also is not going to help because you have wires in your rack, you have metal in your rack. Your rack is also having a lot of, let's say, supporting parts, which is made of metal and iron, and all of that will block the signal. Not mentioning that the rack is actually lower than most of your microphone stands. So again, your receiver is not going to get anything from the signal. They only get the reflection of the signal, which is going to be very weak already. Now, spacing between the antenna and the microphone should be minimum 3 meters. That doesn't mean it's not going to work if you space away more than 3 meters. Don't misunderstand this. The idea here is not to get something called RF overload, which means your antenna is receiving way more signal than the receiver can handle. You can see that usually in Axiom Digital. So whenever your receiver gets overloaded, just like when you have more gain on your preamp, it will tell you RF overload. So if you are closer than 3 meters to the antenna will send an overloaded signal to your receiver. So make sure your antennas are always retaining at least 3.5 meters from the closest position to the antennas, okay? This way you make sure you're not gonna get RF overload, because RF overload is exactly the same damage as no RF, okay? Now the recommended distance between two antennas is less than 1 wavelength. So remember when we talked about the 500 megahertz, that the wavelength is 0.6 meters or 60 centimeters, okay? So that means the closest you can be from two antennas is, let's say, around 1 meter, okay? More than 1 wavelength. So make sure both antennas are not too close to each other, okay? So the minimum is 1/4 wavelength. Excuse me. But recommended is 1 wavelength. So the recommended is to be 60 centimeters when you're operating in the 500 megahertz. Now I see a lot of people putting one antenna on one side of the stage and the other antenna on one other side of the stage. And that is completely wrong. Doesn't work. You are way more than 1 wavelength, okay? So in that case, what happens here is you might have a chance of both antennas getting both multipath, and both antennas will not receive the signal properly, okay? So the misunderstanding of multiple antennas is not to get extra coverage. It's to combat something called the multipath, okay? Now, whenever you're using in-ear monitors, your transmission antenna should be at least 2 meters away from your reception antennas. If you look on my video, you can see I have the dome antenna on my right, and you can see that I have the reception antennas on the left. There is at least 3 meters difference here. So this is the recommended distance. Do not get them both in the same area. What happens is that you're gonna have a leak from the transmission into the reception antennas, and then your reception antennas is not gonna perform to its optimum anymore. As I mentioned earlier, make sure that your antennas are mounted above obstacles, especially on small stages where you have cymbals, microphone stands, and you have people watching. So in this case, you need to make sure that your antennas is not being behind people or behind microphone stands or behind the LED screens or behind anything as an obstacle. Now, humans are also obstacles because, you know, humans are 80% or 70% water, and water is conductive, and we are longer than the wavelength. So that means when humans are standing in front of antennas, they will affect the reception, okay? The attenuation is exactly what we're talking about here. Because of humans containing water, we introduce attenuation. So we deform the signal coming from the antennas. This guy is wearing a body pack right behind him, and the body pack towards the receiver, there's some dip areas, minus 20 dBs, minus 15, okay? So you can see that the human body introduces absorption. Now there are ways around this, which is only existent in the micro body pack from Axiom Digital, and I'll explain that down the line. Now, antenna symmetry, some people emphasize on symmetry, some people say it's not important. You can do 2 antennas. I'm one of the people who like symmetry generally in my life from an OCD point of view. If I have two lights, I like to have two identical lights. If I have two speakers, I like to have two identical speakers. Now, some systems are less forgiving and some systems are more forgiving. So when it comes to Actin Digital, the asymmetry, it's okay, because Actin Digital can actually work this way. When you have passive combining, also it can be working. It will accept different antennas. But with systems like SLXD, QLXD, and ULXD, I would push towards more symmetry. The reason why is that these systems, they use predictive switching diversity. So if I'm using an omnidirectional antenna with a helical antenna, it will mostly switch to the helical antenna over the omnidirectional, even if the helical is getting a multipath. Reasons why is that because of the forward gain on the helical antenna, it will always favor that against the omnidirectional antenna, just because of the forward gain. So what happens is that your system will try to always receive from the helical, thinking that the helical has a better signal, even if the helical has a worse. So symmetry is very important here to have an even chance for both antennas to be favored in the system, okay? Especially if you're using active and passive. This creates a lot of inequality between the antennas, okay? Now I'm gonna go into a small activity, okay? Now, because of the distance here and because I'm on a video call, it might be a bit difficult to get feedback, but everybody try to think for himself and see where is the mistake. So I'm about to show you pictures right now of antennas, and you need to tell me where is the mistake, okay? I will give you 30 seconds to think, and then I will tell you what the mistake is. For those who knew the answer, thank you very much. For those who did not know the answer, now you will know it. So here we have a picture of antennas. They are mounted on top of the rack, good line of sight, and they also pan 90 degrees. But we have problems here. So now I'm going to clock it, and I'm going to look at my watch and count 30 seconds from now. Try to think about what is going wrong in here. In a live scenario, I'll be asking questions to people and I'd like to hear feedback. But in here, we can see a few mistakes and I'll be answering them in 10, 9, 7, 5, 1. Yep. So 2 mistakes. Mistake number 1 is that the antennas are behind a metal fence, and that squared metal fence is acting like a shield. It will not allow any of the signals to pass through. As we know, we are working in the range of 500 megahertz, so the wavelength is 60 centimeters, and these square openings are barely 5 centimeters to 10 centimeters open. So that means none of the signals are going to pass through, okay? Number 2 is that these 2 antennas are very close to each other, okay? They are close, almost quarter wave. This is the minimum distancing between 2 antennas, which I would not recommend. So they need to be at least extended furthermore to be at least 60 centimeters, one wavelength. So these poles need to be longer. So these 2 antennas can be slightly farther away from each other. Okay, let's go to another slide. Here we have an opening ceremony or a baseball game. We have a kid or a girl, I think, yeah, it's a kid, and she's singing the national anthem. And from a top view point, we have the green arrow pointing to where the girl is standing, the camera, and here at that small pentagon house or center, we have the receivers. So again, another 30 seconds from now. Let's think about it. What do you think is the problem? There's a small hint. Antennas are mounted inside that building. So we have 5, 4, 3, 2, 1. And the answer goes, there's also a metal fence right behind that girl, or right in front of her, which will not allow the RF waves to pass through the building. And also because there's no ceiling, that means there's no multipath that will reflect also to the house. Not mentioning that the house ceiling might also contain metal objects that will prevent the waves from passing through, either the ceiling or the wall. Okay, so the right way is to extend antennas right behind the fence on the playground field. Okay, inside the field you'll have antennas, and then there they will work. But obviously, the reasons why the antennas are inside the building, that they thought this is more economic. They don't need to have different sets of antennas for every field in that case. But that is wrong. Every field in that case will require two, let's say, a pair of antennas. And then you need to have a combiner to combine all these antennas to the antenna distributor, and then the antenna distributor will distribute the signal to the receivers. By the way, very strong note here, there are no shortcuts. There's no way you can make it work with no combiner and no antenna distributor. Anybody who thinks like this is trying to make a shortcut for something that will not work. It's like somebody who says, I can make a car drive with 3 wheels. There's no shortcut here. You drive with 3 wheels, you have a big chance to have a very severe accident. 2 wheels is even worse. The car is not gonna even move, okay? So there's no shortcuts in our field or in our professional field. Everything is meant for a reason. And RF accessories are an added accessory. It's a mandatory accessory for people who need to use them in a certain manner, okay? I think this is easy. We already spoken about this. So find the mistake here. There's no need for 30 seconds here. I can give you 10 seconds for this to answer from now. 5, 4, 3, 2, 1. And of course,
Yeah.
antenna in the rack is definitely a no-no. Tell me. Any comments? Kelvin, Shogir?
No. So there's a mic in the room in case you need to hear them give their answer to your questions.
I said at the beginning, because of the distance and because I cannot see you guys on screen, it's going to be difficult. So I'm only giving 30 seconds or 10 seconds for people to guess inside their head. Okay?
Hello, Barry. Barry.
Is the mic muted?
Yes.
Hi, Barry. So there's a mic in the room. If you need to hear
Yes,
them, we have mics for them. If you need them to answer any question for you, there's a mic for them so that you can hear them.
Never mind. I'll get to that. There'll be a Q&A section.
Okay.
Yes,
Okay.
there's a Q&A section that will give the chance for people to ask. Right now, this is like more like a trivia, quick one, just for people to know the rights from wrong. Okay?
Okay.
So shifting to another slide.
Yes, we can proceed.
This is another one also where people do these kind of mistakes. I've seen that happening in many occasions. People place the antennas on the units and they expect them to work, but that unfortunately doesn't work. Minimum spacing is required between the antennas, and it's a big no for antennas in the racks or on the racks. If you have an antenna distributor, by the way, in your rack, you can front mount 2 antennas only at the front, where the rack is facing the direction of the microphones. But if these are backstage, I do not recommend that. This is a big no. This affects the performance of your system. 90% of the calls we get, especially in Africa, about systems that does not work, when I go there, I see things like that. No antenna distributor, antennas in the rack, or antenna farm. This does not work. I've seen broadcasters do mistakes like this. So just a hint, they are using the wall mount antenna. Here's the wall mount antenna. It's very obvious that this will not work for many reasons. And the answer is, as a general rule, maintain line of sight between the transmitter and receiver. This is a floor ceiling. Obviously, this is going to get covered. And the floor ceiling covers, they get also shield covering, fire shield covering, which will prevent this antenna from picking up anything. Not mentioning the aluminum bars that are made for the floor ceiling, they prevent the signal from traveling through. Plus all the AC ducts that are covered in aluminum foil that will add unnecessary reflections and prevent the antenna from picking up any signals. So this is a big no. Now, generally, we have a checklist. You always need to have a checklist here. And I strongly recommend you guys to take a picture of this slide, which is to place antennas above audience and other obstacles as a rule of thumb. That's first things you need to do always. You need to place as close to the transmitters as possible. I know people sometimes are very possessive of their gear. They want their receivers to be next to the front of house. Then that means the antennas need to be next to them as well. And they want the antennas to pick up the signal from more than 150 meters because they are afraid if they put the antennas on stage, somebody's going to take the antenna or take the receivers or something like this. You need to have things done in advance. It's good to have your receivers next to the monitors mixer or the monitor engineer, so he can keep his eye on them. Also, he can monitor things on the spot and do the microphone exchange. It's better not to share microphones with each other. Make sure every act have their own dedicated microphones. If you need to reprogram the microphones, then during your break, you need to reprogram, relabel, and that gives you a chance also to recheck the batteries as well. Of course, finally, make sure your directional antennas are pointing properly to the source and not pointing to sources of noise, like LED screens or dimmer racks. Now we're going to talk about cabling. Cabling is a very important aspect as well. We take cables for granted. Cables are naturally lossy. That means our cables will introduce loss. Okay? Now, before we talk about the types of cables, please guys, do not use video cables for your antennas. 75 ohms cables or 75 BNC cables do not work. They kill your signal before it gets to the receiver. Okay? Plus, the termination of the 75 ohms are much bigger than the termination on the 55 ohms. So they will destroy your BNC on your receiver. Okay? 75 ohms are only for video. Do not use them for RF. Now, we have different types of RF cables. The most famous one that you can buy is the RG58. RG58 is good cable. It works, but I do not recommend to use more than 20 feet or 15 meters to 20 meters long. They have a high loss. They have more than 5 dB loss through a cable. Usually in 30 meters, they can introduce about 9 to 12 decibels of loss. So you can see that most of the gain that your antenna made is going to be lost in the cable. Plus, these losses are when the cable is new. When the cable is old, the cable has more losses. You can use RG213 or RG8X. These are less lossy cable, and they are better for, let's say, they're acceptable in more lengths in that case. Now we have antenna amplifiers, or we call them inline amplifiers. These are only made for long cables. If you need to extend cables more than 30 meters, then you need to use inline amplifiers. Now, when I design systems in general, I make sure I do not use long cables from the start. We have a rule here. You can extend 800 meters of XLR cables before you think about extending more than 30 meters coaxial cables. Okay? Same thing you can use with if you want to use powered antennas or you want to use active antennas, you need to use something called the bias T, which is an inline power injector. Okay? And these are for the systems that does not provide biasing, which is 12 volts bias. Now you need to calculate the overall gain for your antennas. So let's say if you're using a paddle antenna, that gives you between 3 to 10 decibels of boost. With a certain length of the cable, you're going to have 7 dBs of loss, plus 3 to 10 decibels of boost in your inline booster again, if the cable is more than 30 meters long. Then you have another 4 decibels of loss from the inline booster to the receiver. You are still within plus minus 5 decibels. If it's plus 5 or minus 5, you're okay. If it's more than 6 decibels of loss, this is where you start to worry. If you have loss of 6 decibels or 5 decibels, and you are in a noisy environment, and you want to boost, and your boost will equal to 3 decibels of boost, I will choose the loss over the boost. Some people ask me why. I would say simply, would you want to introduce 3 decibels of noise or lose 3 decibels of overall gain with no noise? I would say the no noise is better because I still have options to increase the power on the transmitter. And these are the only ways to introduce power on your transmitters, is when you have noise and you do not want to boost the noise. You want to use padding, you want to attenuate your antennas. This is where you use more power. Never use more power on your transmitters with average reception, with 0 dB reception, or with added boost on reception. If you increase the power, your reflected signal also will get increased. That means your antenna is going to pick up all the unwanted signals and things get worse. Antenna distribution. This is what a lot of people try to avoid because they think an antenna distributor is an accessory. It's not required. It's expensive, but it's also expensive when you buy a system that doesn't work. So guys, I'd like to always to think half a solution always contains half a problem. Buying the receivers without the antenna distributor, you already have half a problem, if not a lot of problems. So if I have more than 2 units, cascade is not possible, especially in rack systems like ULXD quad and dual or Accent Digital quad and dual. If you have 2 units, you can cascade the second one to the first one and use 2 antennas. That's fine. But if you have more than 2 units, this is calling for an antenna distributor. You cannot not use an antenna distributor. Okay? So it will not function without it. It will be compensated in that case. That means your overall reception is going to be jeopardized. Okay? Now, every passive split will take 3 decibels, 3 to 3.5 decibels. So, for example, the passive splitter combiner, the UA221, it's a nice tool. I love it because it's a problem solver, but it introduces 3 decibels of loss. Okay. The other thing is the maximum input level is 30 decibels of gain. So I cannot use it with PSM 1000 or PSM 900. Okay. You cannot split the PSM 1000 or PSM 100 through UA221 to cover 2 areas. There's a different way to do that. And when do I use that? It's in a situation like this. If you have 2 racks that does not have cascade, then you can do this. Okay. Splitting the antennas into A and B, or let's say splitting into A dash, B dash on 2 racks. Now, because racks today have, a lot of them, they have cascade outs, but a typical example of this is when you have the SLXD 4D, the dual SLXD. It doesn't have a cascade out. If you want to use 2 units together to have 4 channels, then you need to split the antennas into these devices. Now, distribution amplifiers is pretty much like what we call the antenna distributor. We have the UA845, like the one I have here in my rack, and we also have the UA844 SW. Both of them are wideband antenna distributors. These are the perfect solutions to distribute across devices. Most of these antenna distributors also have power taps, which can save you from using power adapters. Okay. Active distribution, this is, let's say, level 1, because you can do multi-level. So let's say here we have UHFRs, we have dual UHFRs, or we have, I think this is the accent analog as well. So you can use 4 outputs for 4 racks with 2 antennas. Now, if you want to do a second level, you use the cascade out of the antenna distributor to another antenna distributor, and then you distribute for another 4. So if you need 16 channels, you need to have 2 antenna distributors. Now, what if you have that setup? That setup, you need 5 distributors to cover 32 channels. Okay. First distributor is distributing for the distributors, and then each distributor is distributing to its receivers. Now, the reason why we do it this way and not another cascade or another level of cascade is then your main input becomes, remember, every cascade is 3 decibels, right? If I go back here, we only have 1 cascade, so that's 3 decibels lost to the second distributor, which is fine. But the outputs are not lost because these are active distribution. But in that case here, I cannot do multiple taps. So that means I need to only distribute to main inputs and then 2 subs. So I explained to you the cascade before. You can only do 1 level of cascade. More than 1 level is not recommended because of and filters, and that will introduce a lot of noise. Multiple room or multi-zone antenna setups is very important. We always have these in our designs. Sometimes you have 2 coverage areas, you have 2 ballrooms, you have 2 meeting rooms, and there's a concrete walls between them. Then you need to have antenna distribution system. So what you need to do is you need to use the antenna combiner, the UA221, to combine 2 antennas together to 1 source. You have antenna set A in room A and room B, and you have antenna set B from room A and room B combined together in the UA221 into your main inputs and your distributor, and then the distributor is passing the signal to the receivers. Multi-zone antenna. This is an actual gig in India. Was massive with a catwalk, and they had multi-level of antennas. And here's the schematic of this. Now, I'm sure a lot of people will look at this and think, oh, I'm gonna use the schematic in my next gig. By the way, in here, there is a mistake as well. This is from a real life scenario. I started collecting schematics from gigs around the world for me to see if people are actually doing the right thing or not. And I realized that people still do the wrong thing. And the wrong thing in this one here is that they use the UA221 combiner with 2 helical antennas, which is down here. So they have this system here, the UA221, and they split also another split all the way down to another helical antenna to the end of the ramp or the catwalk. So that is not right. That's not correct. It should not be done this way. Okay. This is the checklist again for the antennas. Keep your gain loss within 5 to 6 decibels, I would say. If it's more than 5 to 6 decibels of loss, you need to have inline boosters. Always check how much noise is being gained in the system as well. Again, less antennas is better. More antenna is more hectic. Okay. And always specify quality wireless systems in your use, which means, again, no shortcuts. Don't use a BLX for a live event with 1,000 people. You're going to have issues. You're going to look so bad in front of people. People are going to call your rental company horrible. You don't want that. Your reputation is worth money. You have 1,000 people, make sure you're using minimum QLXD. Even SLXD might be an issue. You have a main event, don't even think about anything below Accent Digital. ULXD, it's okay if it's backing vocals or something like this. But you have a main event, 20, 40, 60, 100,000 people, don't make yourself a joke. Get Accent Digital. No matter how expensive it is, your reputation is more expensive than that. Because if you make a gig with any system and you have issues, it might be your last time you're going to have this gig in your life. You don't want to be called the guy who looked funny in front of 100,000 people. Okay? And always calculate your RF gain structure with your current antenna system. Now we're going to talk about frequency coordination. This is a very important part of today's training because here we're going to learn about how to use wireless workbench. Okay. Now there are criteria for frequency coordination. The criteria is simple. Number one, every transmitter needs a unique frequency. Frequencies cannot be shared. Like every user needs to sit on his own seat, every transmitter needs its own frequency, its own seat. You need to also consider the total wireless needs. How many total number of channels is required? If that is a hindrance, that means you already know the maximum limit every show you have. So that means you need to be sharing transmitters, which means more headache. Headache in labeling, headache in coordination. That means you need an RF coordinator or even a microphone coordinator. Somebody who's sitting on the table with the microphones labeled. Microphone 1 goes to X, Y, Z people across the show and the day. Where you have already a preset of your coordinated frequencies and you already know about your changes. So you're not going to be using microphones randomly in your show. One of the biggest mistakes is handing microphones randomly. And after you hand the microphone, you start checking which microphone is on. This is a big no. This puts you already in trouble. You start making mistakes when this happens. Plus, one engineer between two engineers, they cannot coordinate properly when they do not have a line of sight between them. So random handing of microphones might put people in trouble, especially with gain structure. So, as a definition for frequency coordination, pretty much a system that's designed to coordinate frequencies for all wireless devices, including talkback systems and other wireless systems that is not meant to work for audio, such as wireless cameras, such as remote controls for your stage, or anything else that's going to be sitting in your wireless spectrum. If that is operating on frequencies that might cause an interference, you need to coordinate that. Okay? You also need to coordinate frequencies outside of your gig. Could be TV, broadcast, could be OB vans, could be even government or corporate. All of that needs to be taken care of. You also need to have the operation range in consideration. You cannot just set it up randomly. Okay? For the show, you need to check where is your dropout points and you mark it. So whenever your performance is happening, you are already telling in advance the people that are performing with the microphones, you do not cross that line or that seat or this row, because then you're going to have dropouts. Okay? Always you need to assume a clear line of sight. Now, when you have less noise, you might have better performance. When you have more noise, you're going to have less performance. When the noise is too high, you might not be able to step away more than 10 feet, 3 meters away from the receiver. And it happens. I've heard people say, like, I cannot step away from the receiver more than that much. This is all because of noise. Okay? So more noise means less terrain. Site survey is very important. That means you do a scan when the place is empty. There's nothing happening. Just check what's going on. Have an idea. Okay? Sometimes the site survey is important even a day ahead, and I'll tell you why afterwards. If your venue is near to something like this, or LED walls like this, which you already seen, this is calling for trouble. You already know something is not going to happen the way you like. And here is why. This is how a clean site looks like. Probably Dubai looks like this. This is a noisy area. By the way, Nigeria looks like this when they are scanned. This is when you have TV broadcast, these squares. And two-way radio when you have, you know, citizen band or CV. A second, my TV kind of disconnected. Let me just reshare my screen. Just give me a second. Nigeria is clean with its people, but in terms of RF, fortunately, it is a mess. That is very, very unfortunate. Going the small ones. Sorry, I've shared the wrong screen. Yes. Okay. Okay, so two-way radios like walkie-talkies and all of that, including talkback systems that we use on stage, cause issues. Now, I will show you how an LED screen causes noise when there is no image, when it's black. So people in the house of worships and the mega churches or big churches, when they go before the ceremony and they power the system up and they put the LED screen on, ready for something, and guess how it looks?
All right. All right. So Barry's system crashed, but he will be joining shortly. But then, like my popular question for today, have you learned anything so far? Oh, awesome. The response now is better than none of last year. Awesome. So what did you learn, sir? Please, can I get a mic for for my comrades? Digital. All right. He wants to share with us what he learned.
My name is Mr. Man, and what I learned quite all right is a lot.
Okay.
One, positioning of antenna, and I discovered something.
Okay.
He mentioned something. He said positioning of antenna
Yes.
at the front of the rack or at the back, and which I discovered they are the ones producing the Shure wireless mic.
Yes.
And on the rack, there
Yes.
is a place that you can put your antenna at the front. And he mentioned something of that is not advisable
Yes.
to put an antenna at the front of the rack like this. So I don't. There's a lot. I've learned a lot, and I need to ask him also because they are the one producing. I have a lot of questions. Yeah, but
Okay.
just hold on.
Okay.
Just hold on to that.
Okay. Thank you. Smokers are liable to die young. All right. So they're not asking you to smoke, but they're saying if you smoke, you're liable to die young. All right. So some of these things are created just to give you some flexibility, not that you should make it a habit. That's why they make some of these things. So the ideal thing, so this is the ideal thing to do. But if you need to improvise, then you have these tools available for you to use. One of not a habit every service day you get. So that's why some of these things are done that way. right? Any other, anybody wants to share with us what the length? Oh, Barry, you're back. So this system is,
Question,
so this
please.
system issue is not just in Nigeria.
Sorry for the interruption.
Let me know if you're ready to join. All right, so before he joins, any
I'm
other person
just
to share with us
gonna get
briefly?
back to the slide that I'm on.
Okay. All right, so Barry's here. Let's wait for him. Okay. Yeah, yeah. Okay, you want to contribute? All right. So if you're listening, to what Barry was saying, he said your antenna should be 45%. Sorry, 45 degrees, not percent. So this is like for discount, so it's percent that is my head. All right, so 45 degrees or 90 degrees. That's why it is this way. Because of space, we can't really do 90. So because of space, so if I do, so if I do, so like I said, sometimes we need to improvise, right? Um, if you say I should do 90 degrees or whatever, that means you guys don't have space to sit. So it defeats the purpose of the training. All right, but then this is just to give you an idea of this is how your antenna should be positioned. All right, if you have space enough, this is what you should do, and not put them straight. So funny. Some even position antenna straight. At the back of this, they just make them straight. I'm like, so why are you pointing to? Just straight. You get so. So even on your transmitters, it should be 45 degrees. All right, Barry, you can continue. You can proceed.
Yes, absolutely. So,
All
can you
right.
see my screen again? Everything is
Yes,
fine?
you can see. Yeah, we're good.
Okay. So, I was going to tell you how the LED screen looks like, or what does it do on your spectrum, okay? And that what happens. Second. So, this is an LED wall without any images, okay? By the way, the longest two spikes, these are your microphones, okay? Or these are like two microphones. But these small spikes, this is from an LED screen when it's black. Now, when the LED is having a still image, like just a photo or a logo or something, it will start looking like this. And if it's moving with strong lights, such as blue and red, it gets even more noisier than this. Okay. So this is why LED screens are an issue. That's why people suffer from them. And when you visualize it and you see it with your eyes like this, you would know why. Okay. Now, we understand that we need to assign unique frequencies. Okay. And the reason why is that we also need to take in consideration something called intermodulation distortion. Intermodulation distortion is a big subject. I'll try to make it really quick. Okay. The idea is we usually put the microphone's frequencies something similar to this: 499.6, 500, 500.4, maybe 500.9, then 500, then 1, and so on, so. And we think that is fine. But little that we knew, if you do not calculate it properly, this is what's going to happen. Every two microphones, when they are close to each other, they generate harmonics. These harmonics are called intermodulation distortion. This is the same way when you have two different speakers put next to each other and you're standing far away from them. You start getting comb filtering on them. You start hearing sounds that are not coming from the speakers. This is the same thing that happens with microphones. So when these two frequencies are far from each other, this is how they look like on the left. But when these two microphones get close to each other on stage, like in a choir, like in a horn section, or like two lead singers, what happens is something that you can see on the right. You can see that there are 4 new frequencies coming into your spectrum. So that means if you have other microphones that are tuned on these frequencies, they will have drop. So in order to make sure that you do not get intermodulation effect, sticking to groups and channels is very important. Already your receivers, they have pre-programmed groups and channels. So you have, for example, group A channel from 1 to 10, or group 1 to 10. So group 1 channel A, B, C, D, E, F, G, H, whatever, okay? Depends on the receiver that you got. Always stick to the same group. So if I look here, this is an example of a receiver. It's using group 1, channel 1, group 1, channel 2, group 1, channel 3, group 1, channel 4. These together are compatible. They are pre-calculated. Whatever is inside group 1, whatever the channel is compatible. So it's impossible for group 1, channel 1 to be not compatible with group 1, channel 4, or to have interference between them. The interference happens when people mix groups together. So somebody's having group 1, channel 1 with group 3, channel 6, and group 17 with the channel A, and group 10 with channel 1. These are not compatible. These frequencies might be either sitting on each other, or the intermodulation distortion between these microphones might sit on one of the other groups and channels. So always make sure, if you cannot do a scan, you find yourself unable to find what's going on, the best way to do is do a group scan first. Every receiver can do a group scan. Okay? Do a group scan, let it select a group, and then within that group, select the channels. Okay? The SelectD has brought in something new. If your system is networked together, one receiver can coordinate the frequencies to all the other receivers using the same thing. And you press the same button over and over again, pretty much. You tell it to go with a wizard, and it will do a scan, and it will select the right group, and it will deploy the groups and channels to all the other receivers, making sure everything is compatible. So people who have SLXD and they have a network switch, you pretty much don't need anything else. You can do that. If you want to connect to Wireless Workbench and have more visibility, why not? It's even better. And that actually brings us to the part that we're gonna fire up Wireless Work. So I'm gonna stop sharing my screen, and I will start Wireless Workbench to show you how we can coordinate the current setup that I have next to me here. Oh, I just open Wireless Workbench. Give me a second. By the way, I did not set that up previously. Because I want to do that with you guys. So it was all intentional. I did not want to prepare that in advance. I wanted to do it on the spot with you. So you can see me guessing with you, scratching my head right along with you from the start. So you can see here already that it is detecting some of my devices. I'm using the Shure AXT630 or 620, I think. It says the switch with the DHCP engaged. If you do not have that, you want to do link local, it will actually work. Just make sure everything is done on dynamic mode.
Please, could you share your screen with us? We can't see what you're doing. We can see you, but we can't see.
Yes, I'm gonna do that. Give me a second.
Okay.
Let me just clear my screen. I'm just preparing Wireless Workbench, so just give me a second. Okay. Oh. Can you see my screen right now?
Yes, we can.
Okay. So this is what happens when you launch Wireless Workbench 7. Okay. You can choose to not show this again. You can do whatever you want. Make sure that your network settings is selecting your cable network, your Ethernet, not your Wi-Fi. And I strongly recommend you guys not to do even firmware updates on Wi-Fi or home routers. A lot of people do this mistake, and they end up breaking the devices. Make sure that your Ethernet switch is not a green compliant, not an energy compliant type of switch. Okay, or get a professional switch like a Cisco or something of that much, with that magnitude, in which you can make sure that your connection is always live. Okay. For Wi-Fi, you can always only do management. You can do the Shure channels, or you can do wireless workbench to manage things afterwards. But it's better to always be with a cable. Okay. Now I can either open an existing show, or I can create a new one. I will create a new one from scratches. Okay. This show name is going to be called Show Gear Training. I can have graphics if I want. I can do the address. I can just put notes, gear rigs for the demo. You can do venue if there's a venue, which is quite good because then if you do a show in the same venue, you know which show to pull out and use the same scan if you want. When I'm done with this, I say finish. And now it's telling me if I want to add any devices. Now, if I want to add any offline devices, this is the window to do it. If you have BLXs, if you have SLX analog, if you have some PSM 900s, you can always do that here manually. But anything that has an Ethernet port, it will already show itself here. Okay. So it's showing everything that I have in my list here. Some of them is showing also, the channel names if you have named them. And this is a good opportunity as well to name your microphones instead of using sticky tape that is horrible on microphones or on devices. So you can rename them. So I can call this, for example, name mic. Okay. This I can call it George. This can be Zachary. This can be Pastor X. We already have a George. Let's rename George to Tom. So this way, you know which microphone is going, and you will see that on the screen of the device. And when you synchronize your device to your receiver, it will take that name. So you don't need to put tapes on your devices with names. Already on the screen, it's showing that. If you need anything, you can get the color-coded caps, and then you can color code these accordingly, okay? Because this is an option you can do. All right. So assign a color. I want to do this, for example, green. I want to do Tom in, let's go here, color. Let's do that red. Can have yellow as well. Do yellow. And we can do blue. The last one, I'll keep it black. That means it's using the original cap of the microphone. Okay. Same thing can be done with the PSM systems. Okay. And also, you can see that I have an 8600, which is my Spectrum Manager, and I have an 8610, which is my show link. Okay. So far, so good. Everything is showing, everything is on, no problem. Now, what do I need to do next? Next is two things. First, I need to get my inventory in. Okay. So what I need to do is select frequencies from inventory from that window here. Just hit that and pull all my frequencies in. And right away, it's going to pull the same color code, and it's also going to tell you that it's not analyzed. That means we don't know what frequencies they are, but I'll hold that for a bit. First thing you need to do right after that is doing a scan. If you have an 8600, you're lucky. You can do a proper scan. If you don't, any device with a network port can be a scanner. So I have Access Digital here. I can select one of them. And I can do a scan. So I can say scan with one source. And now it's just scanning using that particular receiver, using the existing antennas to see what's in the spectrum. Do you know the accent digital is a 470 to about, I think it's here 663. So that's band A. So it's going to scan from 470 to 663 or 636, I'm sorry. Of course, all my transmitters are off except for the body pack that I'm using right now with the lavalier mic. So this is an ADX1. And it should show here somewhere. I'm not sure what frequency it is. Let me just have a look. So mine is on 607. So when I get to 607, it will show a spike up here. You can see that the scan from the device is not very fast. It takes time, so you need some patience. But you're going to see the magic when I do the AD600. So leave it right now. Let it be like this. I'll go back to my inventory here tab. Let me check my AD600 settings. So I'm going to go on properties. And now it's going to open me the device to see what's going on. So let's see what antennas I have. I have all my inputs enabled. I'm actually only using A and B. I'm not using the rest. So what I can do here is I can edit and I can disable those. So I can say disable this, disable this. So this way I'm not going to waste my time in coordination. Now my A and B, I want to limit the band here to be, instead of from low VHF, I want to make it from 470. Okay. 470. And I want the stop frequency. You keep it to the top, but there's no use. I will limit that to 696. The same thing will happen here. So I'll do 470. Then I'll do 696. You can type it. I have my bias enabled. You can switch them on or off, depends on what setup you have. Once you're done, you say apply. It'll update the configurations. That's it here. You can select your compatibility profile. You want to do standard, you want to do more channels, you want to do robust. You can select that here just like you do in Wireless Workbench. And here's your frequency list that will be generated afterwards when we do the coordination. But right now we're set up with the AD600 and the scan is done from the Accent Digital. So you can see it actually picked up my frequency here, which I'm using. But if you have the AD600, you better do the AD600 as a scan. So what I'll do now, I will deselect the Accent Digital here. I will go to my AD600. Let me just expand this a little bit so I can see. Here, AD600, and it's selecting A and B. While while C, D, E, F is not selected because they're switched stall. And I'll make sure that everything else is not selected. Now I'm going to do scan. You can see this is done instantly. I can see how much time it took me to scan with the Accent Digital. But with the AD600, it's done for the whole band and plus, okay, from both antennas. Now, the next step here in terms of coordination, we said we need to have unique frequencies. So the first thing we need to do is let's analyze the current frequencies. And it says some of the frequencies are incompatible. Okay. My PSM 1002 carriers are not compatible, and some of my accent digital channels are incompatible. So what I'll do after this is I will do a calculation. This is where you let the software do the calculation for all intermodulation distortion and all possibilities of interferences. So let's calculate this. It's done. And it's fine. Now I need to also calculate backup frequencies, because I know that throughout the show, something might go wrong, okay? So I will select backup frequencies here if you want, or in your preferences, you can just hit that sprocket here, which is your coordination preference, and you need to change a few things. So now the coordination is done as per United States with 6 megahertz TV channels, which is not very compatible in my region here that we use channels with 8 megahertz. So we'll just select countries with 8 megahertz TV. If your country is listed here, good for you, okay? If not, then just go with, countries with 8 megahertz. You do generic device intermodulation distortion, IMD is intermodulation distortion. Automatically calculate backup frequencies. I'd like that to happen, yes. Minimum spacing from an edge TV channel. So how much spacing from a TV channel, if there's anything, 100 kilohertz or more? I mean, I would advise to go more than 100 kilohertz. So if you can do even 250 kilohertz, that's even better. So you not have any spill. Number of passes, make it 1,000. Number of fruitless experiment, make it 500. This should be fine. And then we say apply. And I close this window. Now I want to calculate again, so it can give me backup frequencies. Here you can see now it's giving me a lot of backup frequencies, more than 100 for all my devices, okay? So I have that much for my PSM here, and I have that much for my accent digital, way more than I need. So I can say simply now stop. I don't need anything more than this. The next in here is to assign and deploy. So I have a camera on the gear, but I mean, it's going to be a small screen right now. Just double check. It's going to be visible. So if I switch to this, so what I'm going to do now, I'm going to do assign and deploy. And if you watch the gear, you're going to find that all the gear is going to flash because it got updated frequencies. So keep watching. I'm going to say deploy all zones. And you can see that the device is just flashed. Now, since I'm using accent digital, I don't really need to go and resync. And by the way, my microphone is still working, though the frequency has changed. I did not even need to go resync my device. Through the show link, a new frequency has been pushed to my device, and we are all good. Okay, so this is what you need to do, frequency coordination, as simple as it looks like. Okay. Now, with Wireless Workbench 7, we also added a feature where you can actually import scans from regions if somebody already did that. Okay, so you can select sources here, either your devices or let me just find a place here where you can actually select from an online database of scans. Just to remember where it was. Scan library. So scan library is an online database. It will access all the scans around the world. Okay. So except I just do a login. Try again. Oh. So if you're a normal user, you can create a username. But I mean, I'm a Shure associate, so I'm going to use my company credentials here. This is one of the features that is very, very unique, and it's very helpful. So you're going to find scans around the world as all these blue is showing you scans right now. So we have scans already in South Africa. We can see scans in Dubai. You can see scans in other parts of the world, in Europe. And the more people use Wireless Workbench and upload their scans, the more information will be available. So let's try to go to where you guys are, Lagos, Nigeria. So unfortunately, there are no scans here yet. I do have some scans, so I'll upload them soon. Probably the guys that show gear, you need to start doing that. Any scans you can do via the AXT 600 or 8600, you start uploading them according to your location, okay? Now, if you go to, for example, UAE, this is where I am. So here there are 3 scans already. So this is a scan in Coca-Cola Arena. So if I hit this, you can see, so this is done by our distributor, NMK Electronics. Okay. Now, can I download it? Let's see. Just a second. So here you can see the scan. It's an SDB3. That's a scan file. So I'll just download that file right now. You can save it on your computer. So let me see if I can just do that in a new folder. Frequency plots. Okay, let's keep the frequency plots. So now what I can do here is I can import, import that file into my scanner and to be visible here. So what you do is so you hit that from scan data, and you go import scan file from file or scan library directly if you want. So go file. Here I see the NMK scan with 8600 open. And you can see it already added that scan into my coordination. So even if you do not have a spectrum manager and you are in an area that somebody else did the scan with, you can use that. For those who've seen me about 4 years ago when I did I think I did a training in the same room that you guys are in. And I gave a copy of the current scan to a lot of the guys in the room to keep it on a USB drive. So whenever they use Wireless Workbench, they can import that scan and use that to coordinate their frequencies, okay? Which is quite a good idea. But now you don't need that anymore. You can do it using Wireless Workbench, okay? The last part of Wireless Workbench right now with the coordination, everything is coordinated, but you can actually monitor every single channel live, like a channel strip on your screen. And you can see Tom here is actually me. I'm wearing the buddy pack here. And I can see that my battery has only 1 hour and 43 minutes, for example. And I'm transmitting at, my gain is 8 decibels. And everything is going fine. You can see even the audio level here as well. Now, if let's say Barry is a superstar or Tom here is a superstar, okay? He's on stage and it's a every single second, okay? So the timeline is very important for you to see and visualize what's going on, okay? So this is a very important feature here. Since I'm using ADX, you can change things on the buddy pack on the fly. So what I can do right now is actually I can change the power right away from here. I will go on transmitters and I can reduce my power so I can save some battery. So I will go on here. Normal power right now. I'm going to go down to low, 2 milliwatts. And everything else, I'll keep it the same. Maybe, let's say I want to increase my gain a little bit. Okay, so my mic offset is 0 decibels, input pad is minus 12. Let's say I want to increase my gain by 2 decibels. So you're going to see that my level has been increased a little bit. And that's on my body pack without stopping the body pack. That's 5 decibels of gain right now. I can do even 8 decibels of gain, and you can see even my levels getting more on the system. And I can even push it to 12 decibels. So now my mic is having actually much more gain on my microphone. But of course, doing this in a live situation is dangerous. You're going to get feedback. I'm going to keep it back to 0. No offset. So we'll keep it like this. Once we're done, we're done. Now, let's say I want to change my frequency. So go on radio. Now, the interference and avoidance mode on my receiver is manual. I can change that to automatic. I can keep the unregistered action blocked. So if anybody tunes by mistake to my frequency, his audio is not going to pass through. Okay? So select from a list. We already have backup frequencies. Let me select that one, for example. And I'm speaking still right now to you. I'm going to switch my frequency. And you can see that my frequency has been switched with no interruption. This is the beauty of using such a sophisticated system. So this concludes the coordination part. Now, I'd like to show you the surprise of today, by the way. I'll just stop sharing my screen for a second. And let's go back to my view. I'm back to you here. So last winter, I went to Turkey in Istanbul, and they had a very famous place that every rental company in the world that comes down there is complaining, okay? But specifically the Turkish, of course. Now, I knew about this before I flew down there, so it gave me a very wild idea that I wanted to do when I'm in Turkey, which is a walk test, okay? So what I decided to do is I will do I'll do a site scanning, okay? And the site scanning means that I want to see what's happening in that site before I deploy wireless microphones. Now the area is the Bosphorus. It's a very busy area in terms of traffic, in terms of wireless. There's a lot of boats, yachts. There's a lot of series shot down there. Most of the Turkish series are shot around the Bosphorus. There's a lot of villas and houses that they shoot inside there. So it's a very busy RF place. So what I did is I went a day ahead, did scans, took the scan information. So what I'm about to play to you right now is a video that I recorded my walk test with, okay? I hope you guys enjoy it. It was freezing cold down there. The temperature was about 1 or 2 degrees. The next day it was snowing. So I might not be at my best during my video in terms of what I'm saying, but the message is there. So let me share that from my other presentation. Okay. We just concluded the wireless workbench. And this is the video that is about to play. So guys, pay attention. I hope you guys get the same channel selection I've done, because on the right channel has the receiver, left we have the camera receiver, my ADX 5D, in which you can know when a dropout happens. I hope in the streaming today I get both channels, But anyway, a little bit loss in the volume, you will know that's when the dropout happens. Okay, so get ready and enjoy the video. So now we're here down in Tarabia. It's freezing cold. We can see the setup down here. We have the antenna set up with the show link, and the system is down here. So we'll do the walk test now down to the pavement. So let's start. Cool. So we are about to walk down the pavement. We're going to see how the system performs. We will be able to show you the timeline as well, which will reflect the signal on the antennas, the quality of the signal as well. And of course, you'll be able to hear the audio. Now, the audio is recorded on both the camera and on a recorder separately along down the system down there. And this way you will be able to hear both the audio at the same time. So the transmitter here is transmitting on the same frequency, both on the receiver with our colleague down there and also on the camera. Trust me, guys, it's very hard to do this setup, especially in this cold weather. So we're doing our best to get the best scenario. We did a scan earlier, by the way, and the spectrum is extremely busy. Finding a empty spot to get a frequency for the microphones is not very easy. And we have been chatting about how important it is to coordinate your frequencies before you deploy them on your microphones a long distance. We are planning to go about 400 meters away from the receiver. We wish we could have done more, but this freezing cold Zemherir, I don't think it's going to be very easy to go more than 400 meters without losing our body temperature. So we are at least about, I think we are about 100 meters away. And I think the system is very robust. It's working perfectly, I think, at the moment. And as you may see, I am blocking the transmitter, so the transmitter is hiding behind my body. So still, I think the system is working perfectly at the moment. The cameraman is asking me to slow down because I'm getting too close to the lens. I'll give him some leeway. My nose is dripping. I'm trying to keep myself warm. It is a tough day. We were not expecting that to be very cold today, but it's good. And by the way, the wireless systems do not perform as well as when it is dry. So it is a bit of a rainy day today. And usually we expect a lower performance. So I don't think it can get. So I've seen that some people are not hearing the audio. So what I'll do, I'll reshare the video again. But let's give a bit of a note here that because the video is uploaded, yeah, so it could be network issues, okay, and it could be also that for any reason somebody did not play the video. So what I'll do, I'll just back it up a little bit and replay it from the top. Hopefully this time everybody can see it, but just as a side note, because this video is uploaded to the Microsoft Teams server, you will see it kind of used to hit play just like you hit a YouTube video and it will stream on your phone. I strongly advise those who are watching on their phones to use a headphone because then you're gonna hear the left and right channels separately, just like I described in the video. So I'll start it from the top again, just for those who missed it, and then we'll start again. So now we're here down at Tarabi. It's freezing cold. We are about to walk down the pavement. We're gonna see how the system performs. We will be able to show you the timeline as well, which will reflect the signal on the antennas, the quality of the, and of course you'll be able to hear the audio. Now the audio is recorded on both the camera and on a recorder separately along down the system down there. And this way you will be able to hear both the audio at the same time. So the transmitter here is transmitting on the same frequency, both on their receiver with our colleague down there and also on the camera. Trust me, guys, it's very hard to do this setup, especially in this cold weather. So we're doing our best to get the best scenario. We did a scan earlier, by the way, and the spectrum is extremely busy. Finding a empty spot to get a frequency for the microphones is not very easy. And we have been chatting about how important is
We've lost you, yeah. We've lost audio. I think he went back.
so now we're here. It's freezing cold. We can see the setup down here. We have the antenna set up. with the show link, and the system is down here. So we'll do the walk test now down to the pavement. So let's start. Cool. So we will be able to show you the timeline as well, which will reflect the signal on the antennas, the quality of the signal as well. And of course, you'll be able to hear the audio. Now, the audio is recorded on both the camera and on a recorder separately along on the system down there. And this way you will be able to hear both the audio at the same time. So the transmitter here is transmitting on the same frequency, both on the receiver with our colleague down there and also on the camera. Trust me, guys, it's very hard to do this setup, especially in this cold weather. So we're doing our best to get the best scenario. We did a scan earlier, by the way, and the spectrum is extremely busy. Finding a empty spot to get a frequency for the microphones is not very easy. And we have been chatting about how important it is to coordinate your frequencies before you deploy them on your microphone. We actually fired up the system before we did the coordination, and the Accent Digital was giving us an interference alert before we calculated any frequencies. So like randomly just synchronizing frequencies, you're definitely going to get issues. So after we did the calculation with wireless workbench, we've chosen a clear frequency and some backup frequencies as well, in case something happens, somebody uses any frequency in the area here. It's very expected, actually, somebody to get on your working frequencies, especially if you are walking a long distance. We are planning to go about 400 meters away from the receiver. We wish we could have done more, but in this freezing cold Zemherir, I don't think it's going to be very easy to go more than 400 meters without losing our body temperature. So we are at least about, I think we are about 100 meters away. And I think that the system is very robust. It's working perfectly, I think, at the moment. And as you may see, I am blocking the transmitter, so the transmitter is hiding behind my body. So still, I think the system is working perfectly at the moment. The cameraman is asking me to slow down because I'm getting too close to the lens. I'll give him some leeway. My nose is dripping. Ah, trying to keep myself warm. It is a tough day. We were not expecting that to be very cold today, but it's good. And by the way, the wireless systems do not perform as well as when it is dry. So it is a bit of a rainy day today, and usually we expect a lower performance. So I don't think it can get any bad than this. If you are shooting a live interview or you're shooting, a short series, TV movies, and it's raining and it's cold like this, things do get worse. And just now we can prove that this is could outperform such harsh environments. To give you also an idea about the capsule I'm using a KSM-11, which is one of our latest capsules. It's our flagship capsule. It's a cardioid, and it has impressed a lot of engineers recently with its sound quality. And we have chosen this to be our mic to be for this test as well. Especially that I'm wearing my jacket and I'm half muffled. My mouth is barely open. So we are quite distance right now from the station, and we will be checking what's going on afterwards. So we are about to hit a curb, and since that curb is not going to have a straight line of sight, we may have some dropouts. May. If not, then that's even better. So got to take a bit of a off turn here to see how things are going. I think we are more than 100 meters away right now. And we are planning to hit close to 350 to 400 meters on average. And see how things will go. This should be a very good test for you. And I hope it will be very beneficial for you down the line to learn how to plan things ahead. And we're half the way through the curb. I'm kind of losing a bit of line of sight. So I don't know exactly what's going back in the main station there, but we will see when we get back and we have a look at the timeline. I expect to have some dropouts where I am right now because we are actually starting to go slightly behind the building. So there's less of a line of sight, plus that the antennas are set up on a floor level. If you set up your antenna slightly higher than, let's say, the pedestrians, the people who are walking on the pavement, you will get even better performance. But I'm happy to say that here it's slightly warmer because we are behind the building. It's less windy and it's fairly better. So we are right at the end of the curb. This area might have the worst coverage of all the time. So I expect the system to have a serious dropout in here from the station. But of course the camera can still capture me, so you'll be able to hear the camera audio clear because they're using ADX5D on the camera. But I'll do a recap. Now we're getting out of the curb. So the video will be shared in the recording. And just to give you a summary, what we did in terms of distance was 470 meters plus. And that's as per Google Maps. So we marked our starting point, as you saw on the screenshots, for those who saw it. Unfortunately, the bandwidth might play games with us. People might hear sound, people might not see the video complete. I'm not really sure. But anyway, I'm gonna make sure that the video will be embedded in the recording and it will reach all those who registered and attended the training. Point of the video was that with a proper coordination, even in the harshest area, you can still achieve wonders. I mean, for a wireless microphone to cross a distance of 470 meters itself is not a small distance. And I hear a lot of people ask me, like, are you sure with just 2 pair of antennas? It's literally 2 pair of antennas, similar to the ones I have next to me here. 2 paddle antennas, left and right, pretty much put in an X, about 1 meter's span each one. We had the show link in the middle. The show link did not even trigger changes of frequencies, not even once. And we were pretty much clear 90% of the time, except when we went into the curb behind the building. That's when you lost a bit of the audio. But as I chose my end point, by the end of the, let's say, the fishing pavement, we had clear audio. And if you see the number of pedestrians on the street, the number of fishing bars, the weather itself, rainy, super cold, people wearing thick jackets, all of that did not make any issues in terms of achieving the, let's say, a successful walk test, in my opinion. I was actually aiming for more than that. Unfortunately, the weather was unbearable. If I was trying to describe it for you guys who are in Nigeria right now, I remember I came to Nigeria when it was raining once, and towards the night, I saw everybody wearing thick jackets, just like the one I was wearing in the video. And when I measured the temperature that time, it was 25, 24 degrees Celsius. In Turkey, it was 1 to 2 degrees windy with sleet, so icy rain. And the next day, it was properly snowing. So it was turning white the next day. So the weather was definitely cold. I mean, for me, I can withstand cold, but that was actually, yeah, with the wind, it was a bit unbearable. So to do what we did that time was quite phenomenal. I was happy with the results. I'm aiming for more, hopefully. Maybe when I come to Nigeria, if I get a chance to do a walk test, I will do also another one in Nigeria, hopefully. So let's see how that goes. We already 4 hours and 15 minutes. I was expecting to do that faster. Unfortunately, we had some technical issues in the middle. So what I would like to do at the moment, if there are any questions that we can answer quickly, we can do that. Otherwise, people can submit questions through Show Gear, and I will answer them one by one if needful. So I will leave that to Kelvin.
Hi, Barry.
You want to take a call on this?
Hi, Barry.
Yes, tell me.
Okay, so any question for Barry? Or do we ask? All right, there's a question for you, Barry.
Okay.
Okay. My name is Chino, so I'm from DCLM Lagos. My first question is, can you talk to us about how you set up the Shure link? Because in the work test you just did, we noticed that you have the Shure link for interference management. How did you set it up? Then number two, is there a relationship between the ROF gain? Like when you talked about the directional antennas, the active directional antennas, you have the ROF gain there. Is there a relationship between the ROF gain and the transmission power of an antenna? For instance, if you have your everything set up properly and maybe somebody walks in with a wireless device transmitting at the same frequency your mic is operating on, is it possible to increase your transmission power such that even if there is interference, that device will not be able to give you a dropout? Thank you.
All right. Did you get that, Barry?
It's a very good question. So to start with, the show link does not need a setup. The moment you plug in a show link into your system with the Accent Digital, by the way, the show link is a proprietary only to Accent Digital. A lot of people think the show link will work with ULXD or with QLXDs or with SLXD. Unfortunately, not. It only works with Accent Digital. Now, once you plug it in, then you are able to send commands to your transmitters. As simple as that. Now, to kind of give a wider and more broader answer to this, the interference management system, brain, actually falls into the spectrum management. So the AD600 is responsible for managing everything related to interference detection and avoidance. So the AD600 is always scanning. It's always keeping, its eyes open on the spectrum. If it notices anything, what happens is that it pulls out fresh frequencies and sends it right away to the receiver and transmitter at the same time, which the show link will send it to the transmitters in that case. But if the show link is absent, then that what's not going to happen, even if you have the spectrum manager. So it's part of the ecosystem. Now, the other part related to RF gain. I'd like people to not misunderstand this one because a lot of people do. More RF gain doesn't mean better. Also doesn't mean worse. Thing is, what makes your system more reliable is a long frequency coordination or a long scan. So when I did a scan here on my wireless workbench, I did a one shot. Now you can select, instead of one shot, you can select continuous. And what continuous does, it keeps scanning for a longer time. So if you have an 8600 and you saw how fast the 8600 can do, it can do multiple scans over and over again. And usually we do it for about 45 minutes to an hour and a half. I remember when we did the Experience 13th, we were down in Lagos. We did about an hour and 45 minutes scan before the show started, just as a precaution to see if there's any random frequencies, anybody with a random frequency that might come up, and we registered this. And then we did the final coordination based on that scan. in which even the little accidents might not happen. So even if a police patrol comes in and they created a harmonic on a carrier that we have, this will be taken in our scan. Now, if somebody randomly opens a transmitter in your show, number one, why would somebody have a random transmitter in your show? So let's face it. I mean, if you are in a church and you are in control of your wireless microphones, anybody who's gonna fire up a wireless microphone, it's either somebody who has no idea what he's doing and needs to be escalated out, just escorted out, sorry, or somebody who had randomly had a wireless microphone in his pocket, tuned at the same frequency that you have, and it's very unlikely to happen. But if you have a proper setup in your place, it should not happen. Now, if you have more gain on your antennas, if somebody out of your premises has a microphone with the same frequency, you are more likely to have problems. Get my point? So this is when I try to emphasize on your wireless gain. Your wireless gain should be within the system requirements. If it's an enclosed in your facility, in your house of worship, in your company, in your theater, then something behind the walls is very unlikely to affect you. What is going to affect you is something that is within your premises. So if you have smaller wireless microphone setups in breakout rooms, or smaller gatherings, or smaller, let's say, gathering of worship, then all these microphones need to be coordinated. You cannot just coordinate one of them and leave the rest. You cannot just say the rest are far, this one is okay. Do not prejudge this thing. And on the other hand, do not make your system work at high gain. Do not push your gain up thinking that this is going to make things better. This is not right. Always keep your system within 5 decibels of gain. After calculating your losses of the cables, your losses of your patches, your let's say whatever you call them, the cascades, your splits, all of that, you put it on a paper, you calculate the pluses and minuses. If you are within 5 dBs plus or minus, you're good. If you're above 5 dBs in boost, you need to attenuate your antennas. If you are more than 5 dBs or 6 dBs of attenuation or losses, then you need an inline boost. But as I said, you need to be wise. You need to be able to assess the situation. If you get a lot of issues and dropouts because somebody else's wireless microphone across the building somewhere else in the road is affecting you, then more sensitivity is not good for you. You need less sensitivity. That means you need less gain. Okay? So it's good to be a good judge in this. Same thing with your microphones. Do not use high power on your microphone just because you can. This is not the purpose of it. The only time you use high power on your microphone, if you need to use attenuation on your antennas, as in less sensitivity, less overall gain on your antennas, then higher gain is better. Power on your transmitter is better. And it's only when you have issues from noise. Now, practice makes perfect here, okay? But a lot of people do the two untouchables: more power and more gain on the antennas, and then they get more problems, and that is known. This is not right. Okay, I hope this answered this question.
You're clear, right? All right, he's clear. All right, so we're going on a break for 5 minutes. See you back.
Well, I mean, this is the end of the training, by the way. So if you guys have any questions right now, we can actually answer them. If not, and anybody has questions that they want to register afterwards with Shogir guys, you can send them an email or write them on a paper, and you can send them to me, and I'll answer them to them. The video was let's say, the icing on the cake, just to show how proper coordination can help. And if there are any questions at the moment with anybody, we can answer it. Otherwise, that will be concluding the training for today.
So we still have practicals here to do. We have practicals here for the people to do, and then we have 2 more classes to take, 2 more modules rather to take. But before that, the facility needs to change the power source to a bigger generator for us. That's why we need to go on a break now. So we can answer those
No
questions
problem.
after the break. All right. Thank
Okay,
you.
then in that case, I prefer if you then send them in an email form because it's
Okay.
getting quite late in where I am.
Okay. 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 All right. All right. Walk around that.
Okay,
Yeah.
no
Great.
problem then. Thank you very much for allowing me to be on your session and looking forward for more of this. Please reach out to us if you feel for anything through the gear, and hope to see you soon.
All right. Thank you, Barry. Thank you for your time. Thank you for the class. We learned a lot so far. All right. Let's take 5, and we'll be back shortly. But before that, please help me greet my HOD of the show. My God. Sugar Sound Reinforcement Training, Mr. Big Man. That's my HOD. So Big Man is here to score me and assess me. So please, even if I don't do well, please tell him I'm doing well. All right, because my salary is depending on his scores. All right, thank you. Please, let's take 5, and we'll be back shortly. Thank you.
Thank you, everybody. Thank you very
All
much.
right, thank you, Barry. All right. Good afternoon, ladies and gentlemen. Thank you for your patience. Thank you for your time. All right, so we'll be going into introduction to wireless systems basically. But before that, um, my HUD wants to say something to us. Then we'll start. Sorry? It's not working? Engineer, they said the speaker is not working. All right, let's welcome Mr. Bigman as he. Um, no, no, please, I need microphone, sir.
Hello. Good afternoon, gentlemen and lady. There's a guy that asked the question just now about the setup of, no, not you. Why we have this setup like this? Is he around? If he's not here, then don't need to answer the question. Eh? Is he around? Eh? You heard the question, right? He's not around. You brief him. But it's not nice now. The person that asked the question is not here. Huh? Should we wait for him? We don't have time. Okay, well, you guys have listened to, but I just needed to quickly clear this so that when you see stuff, when we do stuff, it's not fancy. Like I heard somebody say, it's XY. Yeah, it's not XY setting. There's a reason why you have this setup this way, if that makes sense. All right, so you heard Barry saying something about polarization of microphone of the wireless system. So it's the orientation, basically. All right, so if you remember there's an antenna here. So this is the polarization of this antenna, all right? So this is vertical polarization. But not everybody talks this way. Some people have to talk this way, all right? Now, if I take this, if I move my mic this way, it means I've changed the polarization to what? Horizontal. Now, if this microphone, if the antenna is straight, okay, bring. Or can we use something to demo it? Okay, let me use my phone. So let's say this is the antenna, right? So the antenna is this way. This the paddle antenna. Okay, it's straight now. So it means we're at the same what? Polarity, right? So what if I'm here now? It means the transmitting antenna is what? On horizontal polarization. Though it's working, but what we're trying to do is to have a coverage so that when you sweep from vertical to horizontal, we can still give you that coverage. That is why we have to what? Pan the antenna this way so that you have that in between coverage. Basically, that's what it is. Then sometimes you can also have a setup like this. You can keep one antenna this way, one this way. Right? So this guy is doing the horizontal, and this guy is doing vertical just because the way people move microphones, basically. Is the person here now? It's not still here. But if that makes sense to you. All right, so, and the distance, like I said, is space them about 1 meter apart. All right, there's a way to calculate it. All right, it's the speed of light over what? The frequency. So speed of light is about 300 million, right? Over, this is about 500 megahertz. So if you do 300 million divided by 500 megahertz, that will be 500,000. So you have like 0.6 meters. You remember I said you space it by what? A wavelength. Right? So to get the wavelength, that's just it. So you space it by that distance, and that settles it. If that makes sense to you. All right, can I go now? Eh? All right.
Thank you.
Any questions? It's clear, right?
So you invert the polarity, basically. All right, so wireless systems. So Shure has a lot of models, right? But we'll be touching on the ones that apply to Nigeria and the one in our region. right? So let me test this microphone. Okay, it's working. All right, great. So before I go into this, these models were not created to be better than the other one. That wasn't the reason why Shure created QLXD and BLX and SLXD. No. I know we human beings, we like competition. I'm better than Big Man. You get? I'm better than Big Man. I'm bigger than Big Man. You know, like those comparison. But that's not the purpose for why these manufacturers create these products. It's to give you variety, and then it's to give you flexibility, right? So it's not about better. So if I don't need an SM58, a PG58 is appropriate for that job, not an SM58. If I don't need a Beta 87, right, then Beta 87 is useless to me at that point. I don't need it, I don't need it. It is not applicable. It is not, I don't need it. So that's why these things are created. Not that Beta 11, no, that's not why. That's not why. So if you need more sensitivity, then you have this. If you need a bright sound, you have this tool to work with, right? A shovel is not better than a cutlass, basically. So SM58, if you need a warm sound, this is what you can use to create that sound. If you need a bright sound, this is what you have. If you are working in an environment that has a lot of activities, activities, you have these tools to work with. It is not to say that this is better over this. Yes, you have better performance, yes. But then again, it's also considered the budget. So if you make so imagine that Shure has just one microphone and its accent ADX. A lot of us will stop using it. You know, we use our Devon. You know, I mean, it's heavy, right? So I just took my Devon. All right, so it is not better over any other one. It's just application and purpose, basically. All right. So that's the BLX. BLX is the entry level for the wireless system, wireless microphones. That's the PGXD, but like I said, PGXD is not sold to our region. If you go to US, to Canada, you see those PGXDs. All right. So PGXD is the transmission is digital, but the BLX transmission is analog. All right. But PXD is not sold in Nigeria. If anybody has any PXD in Nigeria, then the person bought it in Canada or US or America. All right. But the BLX, you can use up to you can have up to 12 channels per band, 12 systems per band. Right now, BLX has there's a K3E, there's a K3E, there's the H8E, there's the H8, all those frequency bands. So you can have, so for example, it means, so what this is saying is you can have 12, you can use 12 of the H8E in one place, and you can use K3E, 12 of it in the same space. All right, and it has a scan. Please, can I have the BLX? Right, and it has the group and the channel. You know, you can do. Okay. So yeah, it has a group and it has a channel. So once you press that, you know, you scan. You know, it scans for free frequencies, and then you match that with your transmitter, and you're good to go. So it is very, very easy to use. All right. Up to 14 hours of continuous usage. Now, Shure, what I've noticed personally is that Shure microphones, the battery usage is very good. It doesn't it doesn't consume battery. You know, I was going to speak like a Nigerian. It doesn't chop battery. All right. if your microphones, now we're talking about Shure, right? For other mics, I don't know, but if your Shure mics are consuming a lot of battery, then it means you need to check your battery. Are you using the original Duracell? Are you using original batteries? That could be the reason why your batteries are draining so fast. All right, and then up to 91 meters operating range. Line of sight, all right? Line of sight. Don't go and hide the microphone and say, this mic is dropping out. Line of sight, all right? And then it has XLR output and your jack output, basically, all right? It is rugged, but please don't drop it. Yes, because she's Cardi B. You're not Cardi B, all right? And that's violence, by the way. All right, and then it comes with options, legendary Shure microphones options, PG58, SM58, Beta 58. Those are the options that comes with the BLX. Any other thing, any other option other than that is not Shure again. All right, then now the GLXD Plus. Now GLXD Plus is the replacement for the GLXD Advanced and the GLXD. You know, so there was the GLXD, then they now discarded the GLXD and brought the GLXD Advanced, right? Then they're like, no, let's discard this GLXD Advanced, and then they brought GLXD Plus. Now this GLXD Plus operates 2.4 gig and 5.8 gig. All right, so 2 frequency bands. So it means you can scan within 2.4 to 5.8, and then it comes with a battery that's rechargeable. Right, so you can recharge it. Most churches like this microphone because of this battery. Trust me. Yeah, they like it. Your church. All right. No. Seriously, they like it, you know, because of the battery. So you're not worrying about battery. Right, just charge it. That's all. And you're not even buying the charger for it. You know, it comes with it. So I mean, it's good. It's good for ministry. Battery life up to 12 hours. Right, 12 hours. No church service runs up to 12 hours. No. Oh, sorry. Sorry. Okay. All right. Then up to 30 meters of range. All right. But then you can't change the capsule. For the GLXD, you can't change the capsule. Even for the BLX, you can't change the capsule. You can't replace the capsule. They are fixed. All right. Yes, it's inbuilt basically. Yeah, yes, you can't change it. But you can buy the transmitter that has that head that you're looking for. All right, big man, thank you. Have a good day, sir. Thanks, sir. All right, so you can't change the capsules. All right. So if you need SM58, just buy GLXD2/SM58 and that's it. If it spoils, just go and buy another one. All right. And then it's easy to set up. Yeah.
Is it possible to get another handle and scan
GLXD, yeah? Yes. So GLXD does not have G51, H9, K3. GLXD is 2.4/5.8 gig. Anyone you buy is this frequency. So yes, you can just buy. So that person that asks if somebody asks a question that what if somebody has a microphone that is not interactive? So with GLXD, this is very possible. Trust me, it's very possible. So if I have my GLXD and I go to your church, and I know I know that you owe me money, I can just own my GLXD, and that's it. All right. And it's easy to set up. I mean, the frequency coordination is very, very easy. Very, very easy. One thing I like about Shure is their mics are very intuitive. You don't need to go to school to operate them. All right. All right. So legendary Shure microphone options: Beta 58, SM58, Beta 37. You have those options. They don't have PG 58. All right. Now that D means it's a digital transmission. Between the receiver and the transmitter. Between the receiver and the transmission is happening digitally. Your BLX, the transmission is analog. All right? We're not going into transmission. Maybe when Destiny comes up, he'll touch on transmission. All right? And then it comes with options. You can use your body pack if you want. You can use your handheld if you want. And then it has a guitar pedal system. Media people. All right, one house, please. Then it comes with accessories. It comes with the mic cup. It comes with the nylon. It comes with the carton. And the basic accessories, you need to work with it. And like I said, it comes with the battery. All right, the battery is rechargeable. And you can use the system 11 Max systems. All right, 11. But please don't use 11 GLXDs. You have issues. I mean, you're prone to have issues with GLXD. You're very prone. Because 2.4 is a consumer band. Your Bluetooth operates within that range. Your Wi-Fi operates within that range. all right, your hotspot and all of those things is within that range. So I recall one time I was in church, and then I said, let me hotspot my phone to my system, and I noticed there was a dropout. I was wondering, so where is this coming from? I was like, oh, I turned off my hotspot, and I was good. All right. Sorry? Yes. So that's how volatile it is. All right. So SLXD, you can use 32 of the SLXDs per time. All right. Then it operates within the UHF. So there are different modes of transmission. You can transmit within UHF, like the GLXD. The GLXD is 2.4, right? This is UHF. You have VHF, all right? But most transmission has moved away from VHF to UHF. Now, but you have less transmission around the 2.4 gig. You might be wondering, so why are we fighting about this UHF band? Let's just go to to 2.1 gig to 2.4 gig. But the issue is, so within the UHF, right, you need less transmission power, and you need your antenna doesn't have to be long or big. You're good. If you require your antennas, for those of us that are not Gen Zs, that have these long antennas that go up, they have to tune your TV. All those VHF this thing. So VHF, you need a long antenna. Your car, your car has a long antenna. Those old cars have long antennas, VHF. All right. Now guess what? For the 2.4 gig, you don't even need antenna. You don't even need antenna, but you need a lot of transmission power. You need a lot of it. So UHF is more appropriate for transmission. You don't need a lot of transmission power. You don't need big antennas for that to work. You're good to go. So that's why everybody is within this range, and it's safe. It's safe. All right. So it comes with the battery. It comes with the battery, AA battery, and you can use the rechargeable battery with it. Up to 8 hours of battery usage for that, and it covers up to 100 meters. That's a long distance for you to use. I don't think any stage is okay. I might be wrong. So, it gives you 100 meters of coverage, but then you can change the capsules. So if you don't like the SM58 capsule, you don't have to go and buy the whole transmitter. You can just change the capsule to Beta 87 or KSM 11 or KSM 9 or KSM whatever you want. All right, you can change the capsules. It's also easy to use. So you can So SLXD is networkable. It means you can plug your Ethernet cable to it, and then control it on your system. All right. So it is very easy to use. Actually, it is durable. It's reliable. It is rugged, beautiful. Please don't drop your microphones. It is bad habit. All right. Multiple system management. You can manage those different systems on your wireless workbench. All right. Then your accessories, your cup holder, and all the other packaging materials it comes with. And then it comes as a single unit or a dual unit. So there's the SLXD. There's the SLXD. There's SLXD 4D. Then there's the SLXD 4. All right. So anything 4 in Shure is the receiver. Anything 2 is the handheld. Anything 1 is the body pack. All right. So I'm saying this so that because I might say 4 and then forget that I have a mixed class here, right? So that's why I'm explaining the terms. So it comes with 4D, that's the 4 dual, and then just the 4E. All right. And then you can use a body pack. I'm using the SLXD body pack right now. Sounds amazing, by the way. And you can, so we tip our microphones to indicate. Okay, so this is pastor's mic. This is choir master's mic. This is, with the SLXD, you can actually have all of that on the mic, on the transmitter. Yes, so you can have all of that written here, so you don't have to tape it. All right, you don't have to tape it. Okay. Then the QLXD. All right, so QLXD does 67 channels. 67 channels. Now it's interesting. The SLXD sounds almost as good as the QLXD, all right? But the difference is the number of systems you can deploy per time, per venue. So I can do 67 of the QLXD. I can only do 32 of the SLXD. That's like basically just the advantage of the QLXD over the SLXD. All right. So if budget is a challenge to you and you want to still get an amazing microphone, just go for the SLXD, because the QLXD costs more than the SLXD, but the SLXD sounds really nice. All right. It comes with the battery as well. You can buy the rechargeable battery and 8 hours of battery usage and 100 meters. You can see that most of the features here still apply. So 100 meters, SLXD is 100 meters as well, and it is networkable. All right. Okay, and then one of the advantage is encryption. So it means I can decide and hide my data so that somebody else cannot tap into that data. Now, some of these things we really don't bother about them here in our region, because there's nobody bothering about what you're talking. In advanced countries where you have spies and all of those things, all right, people are going to want to hack into your microphones and all of these things. So some of these mics are made in such a way that you can encrypt your audio so that the next person does not have access to your audio or your data. All right, so QLXD has this, but your SLXD does not have this. So this is one of the advantage over the SLXD. Then we have the ULXD. So ULXD, you can do more than 90 channels per time of that, and it comes with an option of the transmission, UHF, VHF, and then the rest comes with the battery. You can also use the rechargeable battery for that, and battery life of 8 hours and coverage of 100 meters. All right, line of sight. Please, line of sight is important. Don't hide your mic and say it's supposed to cover 100 meters. Line of sight. All right, and you can change the capsules. It's also networkable. You can plug your mic straight to your computer and then do your scan and your coordination. It is durable. It comes with the legendary Shure options. All right, SM58, Beta, KSM, and all of those. All right. Now, the high-end microphones don't come with PG. So PG stops from BLX. You're not find PG with SLX because it's a waste of money. Why buying a Benz and then buying a Toyota engine to use with it? All right. Sorry. So I'm sorry. Sorry. I mean, I'm just saying. Because the engine will limit the speed of the car. All right. So it is durable. Yeah, it has a metal case. It has a metal case. Then you can use the wireless workbench or the Shure Plus channels. It comes with accessories, the mic up, and the rest of that. It comes as a single, as a dual, and as a quad. All right, so 1 channel, 2 channels, and 4 channels. Yeah. So if budget allows you and you have a lot of microphone needs, just go for the quad. All right, so with the quad, you're not bothering with plenty antennas, so that Barry not come and say, when I went to your church, the antennas masking themselves. So you have 4 channels using just 2 antennas, so you're fine with Barry, no police. All right, and then the plug-on transmitter. So Shure has a plug-on transmitter that you can use. So this ULXD has, so it means that I can buy an SF50, for example, and then use a plug-on transmitter and then make it wireless automatically. All right, and that's what that means. Then encryption, you can encrypt it. All right, wireless workbench and the rest. Do I need to scan this thing? Sorry, it's not working. Please, can you help me? All right, then the next one will be the accent. Yeah, the accent digital. Next slide, please. So with the accent digital, you have 2 series. You have the AD series and then you have the ADX series. But with the AD series, now some of these differences might just be like 2 or 3 differences from the AD and the ADX. All right, but it counts. For us here in Nigeria, we are good with AD, but if you're doing a lot of high-end or high-profile jobs, you might consider going for the ADX. But you can do up to 84 channels. Right, up to 84 channels. So if I have, sorry? Yes, 194 channels, yeah. So if you have an orchestra or maybe like a crusade and everybody in that crusade needs a mic, right? You can consider the accent. It gives you that flexibility to have as much as 194 channels. In Nigeria, I don't think there's any show that needs 194 channels. All right. Then the operating frequency is UHF. You can use AA battery. If you can afford the rechargeable battery, you can use AA battery, and maximum life of 8 hours, 30 minutes, 100 meters coverage. You can change the capsule to whatever head you want to use. All right. So right now, Shure would even recommend that you use. Like don't go for SM58. That's according to them. All right. No, don't use SM58. You're using a Toyota engine in a Benz body. So they will recommend you don't use this. But if budget does not allow you that, then please go for what you can afford. All right. It is networkable. All right, it is networkable. You can plug your system. You can plug it straight. So this is Accent Digital. All right, this is Accent Digital. Very nice. Very nice. It doesn't come with. It doesn't come as a single unit. It's dual or quad. The big boys don't. They don't like mingling with all these single people. All right. So it comes with a dual. It comes as a dual or as a quad, 4 channels. All right. You can deploy it to your wireless workbench, and you're good to go. It is rugged, like really rugged. It is rugged. It is really rugged. So we get to questions, sir. All right. It has a plug-on. It has a micro body pack, really small. And it's Dante networkable. So I know Dante is a new concept here in Nigeria, but we're getting there. All right, we're getting there. We're currently running Dante here. All right, so we're not saying something or we're not preaching something we're not doing. All right, so Dante is a new concept here in Nigeria, but I believe it's getting very popular very soon. All right, it will be popular very soon. So you can plug this to your Dante, and then you don't need to plug in your XLR. All right, and audio over Dante is a whole lot better than using your analog cables. It's a whole lot. The audio fidelity is higher as compared to using your analog cables. And if you're looking at reducing your cable runs, this is your guy. So just have have Cat6 cable patched into, and you can even daisy chain them. So you don't even need to run a single Cat6 into your switch. You can daisy chain all of them, then take one Cat6 from all your 194 channels into just one switch, and then to your console, and you're good to go. All right, no cable needed. The only cable you need here is your power cable. Even your power cable, you can discharge your power cable. Yes, and you're not having power drop. Yeah, that's how sweet it is. All right. So the higher the system, the more flexibility you have. All right. All right. Please, my system should not go off. Oh. All right, then we have the ADX series. Like the mic barrier I was using in Turkey, that was an ADX system. I don't think there's any church here using any ADX yet. All right, but the ADX is more advanced than the AD series. All right, so the difference between the AD and the AD series and the ADX series, they're really minor. All right, so you can use a show link on your ADX. It has a micro body pack as well. So you can change the frequency without even noticing that something has occurred. It will avoid frequency interference that you don't even know that something has happened. That's how seamless the technology is. All right. So if you want a system where nobody notices anything, please, this is your guide to go for. All right. Then let's talk about the PSM systems. Your personal in here, the PSM 300, all right, which is more common here, personal monitoring system. So this is a single channel, and it comes the option of a plastic and then a metal case for your body pack. So when it comes to the PSMs, this is your transmitter. This is your receiver. All right, this is your receiver. This is your transmitter. In your wireless microphones, the reverse is the case. So this would have been your transmitter. No, this would have been your receiver, and this would have been your transmitter if it was a wireless microphone. But in the PSMs, is the reverse. Okay, and this is a single system. But this comes as a and this comes in dual as well. The PSM in-ears comes as a dual comes in the dual option as well. Then you have the PSM 900. I think there's a few people that have the PSM 900 here. Yeah. All right. So this does not have. You can't network this. The PSM 900 and the PSM 300. There's no network for them. You can't connect them to your system. So you have to do your coordination physically on them. All right. Then we have the PSM 1000. All right. Which is like their father. All right. So the PSM 1000 comes as a dual system. You can even mute your audio. It's sweet. It's good to use. All right. And it is networkable, so you can daisy chain. The power, even the power cable, you can daisy chain it. All right, so to reduce your cable run, it makes your rack neater and your setup neater. All right. No, there's no Dante with this one. There's no Dante with this one. All right. So let's look at the accessories. So basic accessories. There are a lot of accessories, but just the basic ones and the ones that you can see them here physically. All right. So you have your helical antenna, which is this one here. This is your helical antenna. All right. So we use this basically for our PSMs. We have just one of these. I have one of these. All right. So this works. So, and like Barry said, this gives you like 14 dB of gain. So just by using it, so you're not boosting anything. Just by using this on your PSM, you have a gain of 14 dB. That's what it means. All right. Then have your coaxial cables. These are your coaxial cables, your BNC cables. That's a BNC. All right, and this is 50 ohms resistance. There are other BNC cables that have like 70 ohms of resistance. Those ones are not really ideal for your RF because they're going to reduce it. Then your UA844 plus. This is the 845. So the 845, your UA845 distribution system, antenna distribution system, gives you the flexibility to switch between the frequency band. So you have from 174 to 2 gig, about. But the 844 does not give that flexibility. So it's a fixed frequency band. But with the 845, you can switch. All right. But the thing is, in Nigeria, you don't need the 845. All right, because your mics will probably fall within 470 to like 600. All right, and your 844 covers that frequency band conveniently, except you're in the habit of buying your mics in the abroad. Then you can encounter those issues of having a mic that has up to 900 megahertz. All right, but I advise you, please don't buy your mics, especially in US. In US, Canada, avoid those regions. Tell your pastor there's a shop, there's a place in Nigeria that sells authentic Shure microphones, and they give you after-sales support. So it's not just sell, right? We educate you before the sales, during the sales, and after the sales. All right, it's not scam, it's real life. Yes, it's free. Sorry, sorry. During your registration for this training, did you pay anything? Okay, okay. I just wanted to be sure that. All right. All right. So I mean, but for real, if I wasn't educating you guys, I would not say you don't need the 845 because the 845 costs more than the 844. For me, I want the money. Like if you're talking about education, but I'm saying you don't need the 845 because the mics will not cover that range. Will not go that low or that high. So you don't need it. You need the 844. All right. However, you need an 844. If you have more than 2 systems in your church, you need a distribution system. All right. I know Nigerians will like improvising, but certain things, I mean, let's just do them. Everything was designed for a purpose. All right. Then you have your paddle antennas, your active directional antennas, the 874. This is it here. Like Barry said, so using this alone gives you 7 dB of forward gain. You're not boosting anything. Then you now have the option to boost it up to 6 dB. All right? But just because it has boost doesn't mean you have to boost. All right? If it's not necessary, don't boost. If you're doing a long cable run, yes, you can boost to compensate for the loss. But if you're not doing a long cable run, please don't boost anything. All right? Just leave it at 0 dB and you're good to go for your show. All right? But I think every church needs this. If you have more than 2 systems, you need this and you'll be fine. All right? Yeah, then you have your antenna combiner for the PSMs. This is a combiner. This is a combiner. All right. So your PSMs does not have left and right antennas like the other thing. So you need to combine the distance so that you can all use that one antenna out. All right. So you need this if you're having, if you're using the PSMs. And please, we need to also embrace IEMs because they are here to stay and they make life easier. They make life easier for us. So we need to embrace this technology. All right. I think that's basically all for this. So any questions concerning this before my learned colleague comes up? Yeah. The price. Okay. We'll talk price later on. I'm not selling. I'm here to teach. All right. Okay, here's the question.
My name is Emmanuel. For the antenna combiner,
I can't hear him. I can't hear him. Is you hearing him?
hello.
All right.
For
Go
the
on.
antenna combiner,
Yes.
is there like a designated number of PSMs for one combiner? Because I'm seeing 2, and you have like 5
I've
transmitters.
yeah, there are
Okay,
about
10.
10.
Yeah. So like how many for? I don't know.
Okay, so when you're doing your system design, um, so when you're doing your system design, you factor in, so how many systems will this take? All right, you factor in how many systems with this. So even your distributor, your antenna distribution, the 845 or 844, once there's a certain range, so once it exceeds 4 mics, you need an additional antenna distro. All right. So during your design, you factor in, so how many systems am I using? Can this fit into this? So if you need up to 3, then you go for 3. All right. So your question.
Okay,
Yeah.
good afternoon.
Good afternoon,
What I want
sir.
to ask is, for example, I have like 2 Shure receivers and one other one that is not Shure. But they are in the same frequency range. Can I put them on the same antenna distributor? It won't work.
Yes, you can. You can, but all right, no, you can't. So short system are they are compliant with other devices. So if that system has a network switch, network port rather, you can't daisy chain them together. But if it doesn't, on the workbench, you even have the option of importing. So on the workbench, you can add microphones other than the ones that are from Shure. So there's AKG, there's Enenza. Okay, so if I go into that now, it's going to delay us. But you can add other AKG, you can add other mics, AKG and Enenza and all of those things. You can add them and then calculate them. All right, so they don't have issues during your production. So Shure is not just looking at Shure during production, other devices that you might likely use during those production. All right.
Okay, just to add something.
This one they asking question. Okay. Thank God it's not
No,
question.
I'm not asking a question. Just to add to your answer to his question. Don't expect to use a Chinese microphone and coordinate them together.
Yes.
Because when a Chinese guy is telling you the frequency is 192.7 megahertz, he's lying.
Yes.
You know, if you do go church where they say the devil is father of all liars, Chinese, not the grand picking. So the truth is, most of the time, what they tell you is not what you see, even with their speakers or whatever they use. So if you're using a Chinese microphone, don't bother trying to do the coordination with Shure. Just you and the Lord will settle it together. But then, if you're using microphones like the Sehenza, for example, that is a respected brand. So they all follow the EU regulations. So they all have those coordination compatibility working together. Thank you.
Please, disclaimer, everything we're saying here is for licensed devices, not unlicensed devices. Please don't bring a Devon and expect it to work like a device has been licensed. All right? So disclaimer, licensed devices. Okay, another question? Okay. Shure is, well, I don't know where Shure is from exactly, but I think it started in the US also. US, yeah, US. He started as a mechanic, a repair technician, basically. That's how he started. Yeah. And then he now started making microphones. Any other question? Okay.
Good afternoon.
Good afternoon.
Thank you so much.
You're welcome, sir.
My name is Emmanuel. So I want to ask a question concerning the now distributor.
Yeah.
So we have a QLXD in my church.
Okay.
So we have this occurring problem.
Yeah.
So when we have, most especially when we're having talk shows,
Yeah.
and some of the panelists have, we have to, sometimes we have to let them know that if you're covering the mic like this,
yeah, you're copying
it starts breaking.
Yeah.
So my question is, because we don't have any of this,
Okay.
so getting this, will you resolve that? Or is there any other thing that's causing that? Because we keep explaining to them that, okay, see, hold the microphone like this.
Yeah.
Don't hold it like this.
Yeah.
You understand? It makes us look like we don't know what we are doing. But I'm trying to find out that if we get this, will it resolve that?
All right. So, first of all, buy this. All right. wait. I'm not done answering now. I'm not done answering. But I said, first of all, get this. All right. How many systems are you using? Yes. How many? Yes. Close to 97. Oh, 7. Okay.
We have seven. We have seven.
Okay, so
with
that means
the belt mic, yes.
Okay, okay.
Yeah.
Body part.
Like for the pastor.
Okay.
Then a handle for her, and we had them. They were like close. The stage is very wide.
Yeah.
It's very wide. It's a big tent.
Yeah.
So they were not too really close to the stage because of that problem. So we had to
Yeah.
move it closer. So the microphones are now like behind, just close to just like this length. But
Yes.
close to sideways. It's close to the LED screen, but it's side. The LED screen is not covering the microphone.
Yeah.
So I'm trying to when I got here. So when they started speaking about this, I was trying to see if maybe there's any way I can get help from this place.
All right. So like I said, first of all, buy this. It's important. Buy the antenna distro. You have more than 2. You have more than 2. You have up to 7, if not 8. You need the distro. Then you have a screen, LED screen. It's an issue. All right. Now, like I said, using the paddle alone gives you 7 dB gain. All right. So this will solve part of the problem. Then the second part is you need to educate them. Don't copy your antennas. Yes. Because I've seen a case where somebody copped. So it won't work well, right? It won't work well, but you won't have that dropout. It won't be that bad. It won't be that bad. All right. So let your church know that they need to get this because of the environment, the LED screen, all right, and then the distance as well is an issue.
Okay. Okay. Good day, everyone. Again, sorry. So, with sound, anything that has to do with sound, placement is important. You carry your speaker and put in another man's church and say you're not hearing yourself. I don't know what you're expecting. So the truth is, how you place something, because why I'm saying this is because I have visited a lot of spaces and I see that engineers are now assistant pastors, meaning they expect miracle to happen with everything. So they'll buy something and say, but it should work because it's original. Like, you did not do something well. You need cane or something. So I don't, like, at the experience of kinds, I don't understand. So my point is, placement is very important. So you can still buy this antenna, buy all the best things, and put them in the wrong place and still get a wrong result. That's what I'm trying to say. So when you have finished getting the right equipment, placement is very important. You can't be putting wireless system. First of all, you don't even have an active system that can help you direct the RF to a particular location. Then you now want to put it near LED
LED
screen.
screen.
Please tell me what you are expecting. The Holy Spirit will come and no, this one go this side. Really, let's be sincere to ourselves. So the truth is, you have to first of all do your coordination properly. You have to learn to scan. I went to a place one time and the person was complaining that the Shure microphones were not working fine. And so I asked him, okay, did you scan for new frequencies? He said yes. I said, how did you do it? He now showed me. He just pressed it into G, moved it down to 1, carried the body pack, sync. I said, and I asked him, how did you know that frequency is free for that space? He said, he's just moving it now. He have changed channel. Now, so they tell you how to drive for this country. Now, why would they get accident? So the truth is, you have to scan. So the device in itself has like a scanning algorithm that helps that it will go through the spectrum and find out, okay, with all this frequency that is in this space, which one is the best that can work here? When you do that scan, it will now tell you the best frequency. Then you now sync your body pack, but that you will not be manually changing it. I said maybe God is telling you which frequency to use, and we don't know. Maybe that's fine. But you have to do that scan, find out, and make sure you put it in the right position. Also, this is an antenna in this is an antenna. So we don't have a. Okay, people want to see my face. Sorry, I like to hide. So this is an antenna. So we don't have an oscillator or a screen to show. But if you hide this, it's just because this place is closed and all of these things are properly connected. If not, if you cover it this way, there will be a dropout. So the strength of the signal will also drop. So it means if usually this microphone can go 100 meter and it will work fine. Once I do this, it may actually just take me for maybe just 50 meters. And imagine you now have all those artists or all those pastors that like entering inside the crowd, and they want to minister, lay hands on the sick and raise the dead. But they have covered the. Sorry, I'm always very funny. I'll try and be serious. They have covered the anointing. You understand? So it's already reducing how much you can achieve. But the good thing again, the reason why he said first of all get this is this helps you to get a longer range. But educate them. It's just like the same thing when somebody cops the mic. Okay, it's not proper. So try and educate your team. But when you're educating your pastor, remember that your salary is at stake. Just try and do it in a way that he will understand. And then, but please, positioning is just very important. That's just what I'm trying to say. Where you place it is important because at the end of the day, he may be willing to spend all the money to get the gears, but then if he doesn't get a result, next